build in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
All right, what's up, everybody?
My man.
Welcome, welcome, welcome. Happy Monday, another week. Getting close to the end of this the school year, I think. I know a lot of students had finals. AP exams were the last week or two ago, and now I know that some of my other students are saying they're completely done with classes, which is cool. Congrats. We didn't have a stream yesterday. I had to take my friends to the airport, so 2 sets of friends to the airport. I've been to LAX so many times in the last couple days, and I myself will be going back to LAX, which is Los Angeles' airport, Wednesday morning, because I'm flying to London to then go to a wedding in Ireland the week after. So yeah, I'll make an announcement in the Discord, but tomorrow will be the last stream for a little bit of time, and then we will come back in probably early June. And we'll see. Usually we kind of do like a little summer break, like mid-June, maybe early mid-June, and then I will start teaching my online course at UCLA starting, I think, June 18th. So then we'll shift the streams over to doing that. I'll be teaching physics, and you guys are more than welcome to attend all the lectures. It's kind of a fun thing to do over the summer, if you're looking to get some extra knowledge in. And then we'll still have office hours for all the physics people in my class, and then I'll have some time available for other math. What's up, Gladiator? Good to see you. So yeah, so that's kind of a little bit of the roadmap for what's happening in the next couple of weeks. But we'll still be back tomorrow, so I'll make an announcement in Discord, and I will remind everyone tomorrow about the same stuff. Let's see, what did I want to do? Oh, I wanted to do the giveaway, or really the prizes for the actual resolutions this year. So let me go do that. Let's see. I padded the announcements at some point. Yeah, this was it. It was in the announcements. So yeah, we had 15 people enter the actual resolutions challenge at the beginning of the year. This was kind of a fun thing we did, as I say it's like a counter to New Year's resolutions. I think New Year's resolutions are kind of like, yeah, but these are actual resolutions, so actual things you can change and do better for yourself. And we had everyone pick one real goal, and we broke it up into 4-week checkpoints, and then we had people like stay accountable. So like every 4 weeks we had kind of a little Google form for people to fill out. Hey, what did I do these 4 weeks? Did I move closer to like what my final goal is? What can I do better? And just that process, I myself, I find, if I have a journal here, which kind of is based on that same framework that we had for actual resolutions, but this one is for 12 weeks and 4 main goals, and so I use it a lot to check in with myself and see where things are going, because otherwise, especially as you get older and you're not in school, you kind of lose the framework for there being like due dates and stuff. You have to create them yourself, so you have to, if you don't set like a schedule and goals and deadlines, you'll blink and then you'll be, I don't know, 50, 60 years old and like, what happened? So anyways, we had the top 5 leaderboard was DM Scrader, 1K Flow, Your Local Hacker, Equity, and Shaq. So I'm gonna we'll do the $50 prize drawing for the top 5, and then anybody else who was still a part of the program but didn't reach top 5, we'll also still do 3 $10 prize giveaways, because I said for every 5 people that fill it out, I would add another $10 to the prizes, and so 15 of you guys submitted, so that's an extra 3 prizes. So let's put those in. And then while we do this, feel free, if you want to submit some questions to our website, we'll do homework questions as well to help you guys out. I know some people still have finals. Some people's school's not over. UCLA isn't over until, I want to say, second week of June. So if you're on like a quarter system, it goes pretty far into June. So we still have those people to help. Okay, so first we had DM Scrader with 13,500. Then we had 1K. So 1K had 12,500. And then we had Hecker with 12,000. And then Equity with 11,500. And then we had Shaq with 5,500. There we go. Cool. Okay, so let's spin the wheel, see who's gonna win the big $50 prize for the actual resolutions, and then whoever wins, I'll ask them if they want to share what their goal was and how it went. Some of them were quite private. I understand. Some of you guys don't want the public to know what your goal was, but I'll let them decide if they want to share it. They were pretty cool. All right, so let's spin. Who's gonna win? Nice, DM Scrader, it's you, dude. Congrats, DM. You've won $50 big prize. So here, we'll tag DM Scrader. Let's see, DM Scrader. So DM, just send me a DM, what prize you want, and I'll get you that. Let me see who else we had on the. I have a big list of everyone that was on it. Let me go to my Excel spreadsheet. It's under drives. Then that's month 1, month 2, month 3. Here we go. This was this. Let me go see the responses. Okay, Shaq. We had Alistair. So Alistair, you want it as well. I'm gonna have to get all the points that people are on there. We had Nello, Mex, River, Magnus, Shantrix, Equity, you're already on there, Equity. Grits, and then Anti-Caffeine. That's an interesting username, Anti-Caffeine. And Eng393. Okay, let me get what the points were for everyone real quick. So I can do this. I'm gonna say coins. Hi.
Silence, wench.
What's this sensation? This silence wench thing? Let's see. Oh, it's disabled in this channel. Sorry, I gotta go do it in the other channel. It's annoying. 1 sec. Please hold. Go find it. Not actually educators. Where was it? New Year's resolutions. There we go. Okay. All right, cool. Let's see. Coins. Alistair. Alistair had 1,000. Okay, cool. And then Nello. Who was Nello though? I don't see Nello in our thing. Okay. Max had 1,000. I think everyone else had kind of 1,000 at this point. Let me see. My pickup line to one of my exes was "Shut up, wench, no one cares." Did it work? Did that work for you, Breasticles?
Totally.
I guess is the definition
Okay,
of
sorry,
like
I was
work.
making sure my mic wasn't muted.
Okay.
Yeah, somehow it did. I
Okay.
don't know how. I was like super shit-faced, and
Yeah.
she was complaining about how like horrible her life was, and in fairness, it really was. But I was drunk as fuck, about to pass out on the floor. So I yelled as she's complaining about this. I'm like, "Shut up, wench! No one cares."
Wow.
And she walked in the room and starts trying to beat the shit out of me, and I'm just laying there drunk.
At least got you the attention.
She's like 5 foot, and then she just like laid down and just went to sleep on the floor with me.
Oh, it's adorable.
Yeah, I don't really know how like it doesn't make sense, but it worked.
It doesn't need to
somehow.
sometimes. Yeah.
Yeah,
Sometimes
yeah.
it just is what it
It's,
is. Maybe you helped her
was-
realize that her problems aren't, really that serious. Like they're more serious. Than
No,
she
they were
thinks they are.
they were definitely pretty serious. I was just trying to-
That's dope. Oh no.
Oh dear. Oh dear.
Yeah, that's why I don't understand. It wasn't even like I wasn't like hitting on her. There was no reason like at all. I was just like, "Shut up, no one cares. I'm trying to sleep." And I guess that's like a good pickup line. I think that's what I'm
Yeah.
gonna start doing at the bars.
Try it out.
Parties,
Let us know
just
how
be
it
like-
works. I don't know if that's gonna play out so well at like public settings, but we'll see.
We'll see. Yeah, I mean, you gotta like.
You gotta shoot your shot. You miss
Yes,
100% of the
yeah,
shots
I
you don't
mean-
take. But also just don't get hit,
Exactly.
please.
Oh no.
I'll try.
All right, let's spin the wheel for the other 3 prizes. Here's prize number 1. Yes, Ace Henderson Hasselbach does save so much time. It really does. Nice. Shaq. Looks like you're gonna get the next one. Good job, Shaq. Here, we'll take Shaq off the wheel. So, we'll say Shaq. And spin for number 2. Ooh! Went to Ethan. Congrats, Ethan. There you go, Ethan. You get prize number 2. And then, all right, so let's take grits off. Final prize. Yeah, it doesn't work. Yeah, when trying to find pH and equivalents. Oh! By the hair. Is it gonna? It went to anti-caffeine. Wow. By a thread. Okay, there you go. Anti-caffeine are the $10 winners. Bro has no eyes. That's terrible. Okay, cool.
It doesn't. There's literally like no eyes drawn on it
Yeah,
at all.
that's got to be Photoshop. There's no way they actually did that. Okay. All right. Nice. So, yep, that's all the actual resolutions. Again, thanks for participating, guys. I hope it helped you out and made your life better. Just like giving a shit, honestly, and being accountable and writing things down does absolute wonders. So, congrats. That being said, I think now we got some questions in the queue. So let's help you guys out with your math and science homework, and let's start the stream. right, welcome over to the Actual Education Office Hours. My name is Dr. Gold, streaming the Healthcare Math Homework, Science Homework. All sorts of fun stuff today. Let's see if I can get my TikTok chat to work. There was an update that just went out. I probably gotta we'll see if this works. Okay. All right. Let's go to the website. See what you guys have been putting in. Partial differential equations. Okay. PDE is a difficult 8. Gladiator geometry
I
difficult
would
7.
give it an 8. I feel
You would
like
give this an
it's-
8? You'd give it more than an 8 or less than an 8?
Well, less than.
You'd give it less than an 8. Okay.
Yeah, it looks scary because it's non-linear, but like
Okay.
you do it in the exact same way.
Well,
The
we'll
same
see.
way that you would normally
We'll-
solve the linear version.
We'll see.
but
Maybe you get picked right off the bat. Let's pick the winner and see what we got. Maybe
We'll see.
it's your day today, Breskos.
You never know.
You never know, dude. But it looks like it tastes today.
Yeah. It was not my day.
No, it's okay. Okay, for the titration with equivalence point at 5.3, sketch a titration curve. Be sure to label the axes, buffer region, and equivalence point, and write a chemical equation for each. You write the chemical during the buffer region occurring at the equivalence point. That's when like the amount of acid and base is the same, isn't that not? I don't think I'm crazy, right? Did you ever take chemistry, Breasticles? Like in college?
Oh, I did. I took it like back in high school.
Did you get AP credit for it?
No, I don't even remember.
What?
I didn't, most of my AP credits, I didn't even like get necessarily. Well, I got credit for them, but they weren't relevant at all to my degree, so they do nothing.
Isn't your degree in math though?
Math and computer science.
Oh, so you probably have to have
So-
some like external science, or I guess that was physics for you.
I
is
do,
what it was?
but I had AP Physics C, so
There you
that
go,
basically
yeah.
just kind of took it over.
Yeah,
But I don't even know if necessarily you need it for comp sci. I know
Yeah.
for math I do, but like I have a friend who I don't think he's done any science courses yet, and he's in the cybersecurity, and I don't think he needs to do any.
Cybersecurity. Oh dear.
Yeah.
YouTube is down. Oh no, what's wrong with YouTube? I'm pretty sure I have it up. Is it not live? One sec. Let's go figure out why YouTube's not running. Could be weird. Let's see. Sensation. YouTube is down. Oh no. One sec. Let me see. Oh, I didn't hit go live. Ugh, I hate it when that happens. Thank you, Sensation. I forget if there's like a 2-step thing here. I gotta start on OBS, and then I gotta go to actual YouTube's website, and then I have to tell it that we're live. It's quite silly. Let me know if that works now. Or actually, it keeps saying like preparing stream. No, okay, I definitely clicked this at some point. It's just screwing up. Come on, YouTube. Okay, now it says we're live. Okay, there we go. I clicked the button. I know I did. That's YouTube's fault.
Oh no.
Yeah. They just, I don't know. There we go. Okay, cool. Great. Okay. Equivalence point of 5.3. That's the pH then, right? Buffer region and a chemical reaction. Didn't expect someone to do math and science on Twitch. We do a lot of math and science on Twitch.
Oh yeah.
And there's actually a whole group of us, Witcher, if you didn't know about this. We're not the only people that do this. If you go to our website, actualofficehours.com, there's a whole calendar here of all the other different math and science streamers. So Penn Center's another math streamer. He's doing some homework help tomorrow. And then Zach as well is doing homework help on Tuesday. And then Eric is kind of a math grad student, and he's going to do some stuff on Friday. So go check him out. There's a whole group
And
of us.
I finally moved, so in the
The near future, Breasticles is joining?
Yeah,
Oh,
hopefully.
wow.
I just gotta set everything up in my apartment, but I'm
Good. I'm so
moved
happy.
in.
The torch shall be passed. And you can do
Yes, it will.
as much hard math as you want, Breasticles. You can just speak all day about crazy math stuff.
Sounds great.
Sounds like a vibe. Okay, let's see. Sketch the titration curve. Okay, let me. So I thought the equivalence point is when you have acid and base that have like canceled each other out. Is what I believe happens, right? So yeah. Okay. So equivalence point. And maybe let's get a graph of this. Yeah, this is all for free. Yeah, it's a nonprofit. Yeah. Yeah. And if you submit a question, Witcher, it gets added to the queue, and we just help out whoever. Yep. It's all free. We've been doing this for about like 5 years now. I think our anniversary actually, our partnerversary or affiliateversary, whatever the next level on Twitch is. I think that comes up in June. We'll do a big celebration stream for that one too.
Nice.
Okay. Let's see. Equivalence point, chemistry, graph. I just want the graph. I just want to see what it looks like. Yeah, see, that's what I thought. I thought the equivalence point, yeah, is right there, which is usually what you're always solving for. Uh-huh. Yeah, okay. And then where is the... Sorry, they said the buffer region? Yeah, the buffer region is down here. Yeah, the buffer is when you still have enough of a weak whatever that it's not responding too much. Oh, this is part 2 to the pH question I asked a while ago. Oh, can you show me part 1 so I know what reaction it is? That would help. Titration. Yes. Yeah, it would help for me to know like what the reaction is. Otherwise, I'm like kind of trying to just guess at this point. No regrets. I love that picture. No regrets. Let's see. Ace is typing. You can just drop it in the chat there too. You don't have to put it. You don't have to submit it to the website again. Bingo. There we go. Thank you. Yes. Okay. Yes, okay. So student is titrating ammonia with HCl. Hydrochloric acid's a very strong acid. I thought ammonia was a pretty strong base. I guess maybe it's a weak base. Usually you titrate something that's a weak acid or a weak base as the... Did you Rascal? That's too funny. Let me see. Ammonia. I thought ammonia was a strong base. I didn't think. It was weak.
That's me in my picture. That's
you.
I look
Joe
like
Dirt.
him. Yeah. Yeah, I used to look like Joe Dirt a lot. That's what one of my ex's parents used to call me. They'd be like, "Yo, it's Joe Dirt." I'd be like, yeah.
Oh
Me.
my god, dude.
Hell no, man. What the fuck, man? Get
Okay.
your ass on.
This is a weak base. This is a strong acid. I know HCl is a strong acid. Usually you want strong something with weak something when you're doing titrations. And then so the reaction that occurs is you're going to have NH3 is going to be combining with HCl to then form NH4 plus like Cl minus is what we would say. I think so. I think that's how it works. Yeah. Right. Okay. And then what will be left? So usually, so then let me draw like kind of what the curve is. So this is going to be pH, and then this is going to be amount of titrant added. So at the very beginning, you will have just NH3. So the amount of titrant added is the amount of HCl that's being added. So at the very beginning, you only have NH3, which is a base. And so your pH is going to be quite high. So it'll be up here. So that will be the pH of your solution. Now, as you add more HCl, what happens is that HCl is going to start whittling away at the NH3 to start decreasing its concentration. And in the process, it will produce more ammonium, which is NH4 plus. And so as that happens, this is going to start like decreasing in pH. It's going to get more acidic until eventually you reach a point where the HCl has completely eliminated the ammonia, And that's when your pH starts dropping like a rock, because now any HCl is getting instantly hydrolyzed and causing there to be a lot of hydroniums. And so your pH is going to get very acidic. So this is what happens. You end up getting this huge drop here. And then eventually it's going to taper off to whatever the natural pH of HCl is. And so this point right here, Dr. G, the OG. Yeah, what's up? We're doing chemistry today, Fat Moxler. This is called the equivalence point. And at that point, what did they want to say? Write the chemical reaction during the buffer region. Okay, so at the equivalence point, you've eliminated all of the NH3. So I would say that all NH3 has been eliminated. And so the reaction that's happening after this is really just HCl plus H2O is forming, well, technically going back and forth between H3O plus and plus Cl minus. And then this is what's telling you what the pH of the thing is. This right here represents the buffer region. And so the reason why it's called a buffer is it's able to absorb changes to its pH. So when you're adding acid or base to any sort of buffer solution, that solution has enough of a buffer, like enough of, like, I would say, like kind of like a bumper system on it, that its pH won't change too much until eventually you wear the buffer out.
Oh shit,
And
not good.
that's what happens here. Eventually the buffer can't take it anymore, and that's when the pH just drops like a rock. So this is the buffer zone. You don't remember this from AP Chem? This is one of the key things from AP Chem. Yeah, so this is called the buffer zone. And so how NH3 is acting like a buffer is you have NH3 plus H2O, and that's going to be buffering to form, I believe, NH4 plus OH minus. Yeah. And so this is the normal, like, buffer solution that occurs. Here, let me paste it in. So yeah, that's and what happens is this buffer, this has like an acid side and a base side to it. So for instance, if you end up adding acid, so if you add acid to a buffer, it will react with this side to form more that way. And if you remember from equilibrium stuff in chemistry, this is also related to Le Chatelier's principle, which means that the reaction will shift over to the other side to try to balance things out. So if you add acid, it attacks this side of the buffer solution, and if you add a base, it should attack this side to then form this way. So yeah, and then let's see. Let me see. What about what's? I'm just double checking here. That's why I got a 2 on it? Oh, no.
Oh no.
Yeah, you need a 3 to pass. Yeah. Oh, one second, I'm hearing something. Oh. Oh, I was like, yo, that's my my TikTok. My TikTok has power-ups. You can make my face look trippy. Wait, what the hell was that? How'd that happen? Something was making noise from the TikTok. Interesting. Or I don't know where that came from. TikTok's always adding things. All right, anyways. So yeah, that's the buffer. This is the buffer zone. And then at the equivalence point, all the NH3 has been converted. Yeah, exactly. And so I would say that this is happening, but also okay. But then this is what happens with the extra HCl. But also, as this was neutralizing itself, you're also producing NH4. So this is the excess HCl. So this is from the excess HCl. So actually, wait. I think this is what we want to say, like, which is past the equivalence point. Let's say that's for here. I would say this. This reaction is when you just have a bunch of excess HCl. In the buffer zone specifically, I think they want just they want this. Yeah. Okay. Okay. They want this, which is the equivalence point reaction. Let me see. Kind of interesting. I don't know about that. Yeah, I want a little pushback on this. Most scary subject ever. I hate ionic equilibrium. It's nightmare fuel. Yeah, because then you have like common ion effect, which starts to like kind of mess things up. And that's what actually happens here, is that when the NH3 and the HCl neutralize each other, you are reducing the amount of NH3 that's available for the equilibrium reaction, and you're also increasing the amount of NH4. And so that's why this tends to move. You miss chemistry? Yeah, chemistry's great. It's like my second favorite subject to talk about. Yeah. Okay. So I would say in the buffer zone, this is what's happening with the neutralization, and then this always happens afterwards to determine what the pH is. But I think this they want specifically for here. And then in the buffer zone, they want to talk about this. You tell me, Ace, if you have the answers to these. I'm curious. I'm looking a little bit at what like AI says for just as like a double check. It is kind of it's like weirdly worded, because technically here and here both of these reactions happen, and then here all that's happening is just HCl is just hydrolyzing. So it's kind of like dealer's choice. This is also chemistry. Chemistry always has like exceptions. There's no one size fits all thing for chemistry. There we go, Ace. Let me see. Interesting. Okay. OChem, PChem, yeah, inorganic chem. Oh god. This is inorganic chem, right? Yeah. OChem to me is, I think, one of the most fascinating things, but it's also one of the hardest because there's a lot of memorizing. PChem actually gets into a lot of like almost physics though, because you're dealing with like wave equations. Okay, so the buffer reaction. I don't know why they marked the HCl off here. This is technically correct. Or wait, what are they doing here? They're saying this is the buffer. I'm curious here. Yeah, I agree this is the buffer. I agree this is equilibrium. And then yes, that this should happen at 5.3. But are they saying like, do they want to switch these? Do they want to call this the buffer region? And no, I think I would call this like the equivalence. It's kind of a toss-up. Let's see. This is the correct answer. Okay, there we go. All right, so let's see. Let's see what the correct answer is. Okay. Okay, so yes, yeah. So I was right when I said this was the buffer reaction. It's funny because, yeah, ChatGPT says this is the equivalence reaction. I'm like, they technically both happen. And then that this is the equivalence point. Interesting. NH4 is reacting with water to form NH3 plus H3O plus. Yes. But I would argue that, yeah, okay. So the HCl has wiped out, at that point, all of the NH3 in the buffer, and all you're left with, sure, is NH4. Okay. Yeah. So, I agree. Buffer reactions should always be equilibrium reactions, because whether you hit a buffer with an acid or a base depends whether it moves from the right or to the left. At the equivalence point, you no longer have equilibrium. Like there's no longer back and forth happening, because you've wiped out all of the buffer. You've wiped out all the tolerance the buffer has, and so at that point, all of the NH4 that got produced from this buffer reaction, and also from this, right, from just NH3 and HCl just like killing each other off, that NH4 then is an acid, and the reason it creates low pHs is it reacts with water to form straight hydronium, which is H3O+, and then this is how you get pH. But yeah, so very interesting how AI and your teacher and probably that other thing, there's a little bit of wiggle room. I think if anything, as long as you're writing down this reaction and this reaction, you get the gist of it. It's a semantics argument for like which one is associated with which region, because technically they happen in all the regions. But okay, cool. Good question, Ace. It's fun. A finicky thing, those titrations, I'll tell you. But yeah, the important thing, I think, Ace, is to know what the elimination reaction is for the strong acid hitting the buffer, and then to also know once that happens, what the equilibrium reaction is, and then to know that third thing, which is once all of the HCl and NH3 have eliminated each other, what's left? It's just the NH4. And why the NH4 makes it acidic. It's because it forms hydronium when it reacts with water. That comes from here. Yeah, need a little bit more practice. Yeah, just so because this was a buffer base with a strong acid, the thing you should practice next to make sure it's really like solidified, you should do a weak acidic buffer with a strong base. And then see if you can get those reactions correct as well, because they're all different. I just have to take Gen Chem 2 over. I was good at titration stuff once. Well, you'll be good again if you knew it at one point. It comes back. It's like a muscle, you know. Okay, let's mark that done for Ace. Yes, yeah, exactly. That would go from low to high, right? Yeah. If you had an acidic buffer with being titrated by a weak base, correct. It would. All right, let's put this in our homework help channel. So this is going to go to Ace. So every time we do one of these questions, the solution always gets put into our Discord. So make sure to go join our Discord and go find all the cool stuff we're doing. And there it is. And then, yeah, you also get a bond coin, Ace, for asking a question. So, congrats. You're at 90. Wow, very close to 100. Getting up there. All right, let's go see what else has been submitted. So, again, if you have a question you want to ask us, go to our website, actualofficehours.com. Type your username in, drag in your screenshot, hit upload. It'll get put there. And then let's go spin the winner to see whose question we're going to work on.
Let's go gambling!
Oh, yeah, the diprotic ones? Yeah, oh my god. So next one is Gladiator. Okay, Gladiator. With a geometry 7 out of 10 question. Ooh, I love this vector method. Your vector methods questions are always really fun, Gladiator. Mainly because I haven't really done them this way in a bit. Let me move it in. You know this one? Okay, cool. Let's see. So it says points A. You're not gonna spoil it? Yeah, no spoilers. Unless I need the help, then I'll tap you in Fembox. Okay. A, B, and C lie on the circumference of a circle such that AB is a diameter. Use vector methods to prove that ACB is a right angle. Ooh. This is your first 7 out of 10? Yeah, yeah, that's what it said for difficulty, right? 7 out of 10. We have AI right now judging the questions as they come in for how difficult it thinks they are. It's kind of okay. Sometimes it's way off, but other times it's been pretty good. It's good for us to kind of screen out who's just sending in like nightmare fuel questions just to like fuck with us. Because then those questions don't have as high of a chance of getting picked. Yeah. You wouldn't call this a 7? What would you call this, Fem? Like a 6? 5 or 6? Okay. So we want to prove that this... You gave this as homework in Calc 3? Really? Oh, wait. You would call this a Calc 3 question? Maybe 4 to 5? Okay, let's see. Okay, I need to prove that this is a right angle. Oh, man. Boom, 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 boom. And use vector methods. So usually this means that I have to do something with like, oh, AC vector, like plus something equals something. I know if this is a right angle. So if ACB is... let's write down things that we know, because this usually helps. This is so easy. All right, well, let's see. So here, I'll say if ACB is a right angle, then that means they're perpendicular. And if things are perpendicular, that would mean that vector AC dotted with vector CB or BC or whatever, that should be 0. Right? So I would say then vector AC dotted with vector, let's say CB. This should be equal to 0. We also know that the dot product of things, right? If you have like, I don't know, x dot y, that's the same thing as magnitude of x, magnitude y, cosine of theta. And so if this is equal to 0, and these vectors are non-zero, that means your theta must have been 90 degrees. Okay. AC.CB is 0. Let's think about the other thing we know. We know that AB is a diameter. So I do know something about AO and OB, and that's that they're the same vector, right? If it's a diameter. Maybe I think I want to involve this. Yeah, AC.CB is equal to 0. Yep, I agree with that. Gladiator. I want to see what other thing I may want to do. Oh, okay. I think I got this. Okay, wait. I know that AC. Yeah, here. Let's define another vector here. Let's define this one, CO, right? So I know that AC plus CO has to equal AO, right? Boom, boom, boom.
Good job.
Yeah, we might get it here. Okay. So AC plus CO is equal to AO, right? And then also that AC solving power functions, maybe power. Okay. So then AC plus CB is equal to AB. All right. So going from here to here is then the same thing as going from here to here. And then also that AB is equal to 2AO. I think I can say that, right? Like going from here to here is the same thing as going from here to here and then doing it again. If they're a diameter. So how can I relate that with CB? I don't want to relate this maybe with a dot product too, though, right? Ooh. Wait a minute. Do I want to do this with a magnitude? I also start thinking maybe something with like the Pythagorean theorem, right? Because if ACB is a right angle, there's a couple properties here that are true. I'm close. Yeah, Fem's like you're close. I would say also magnitude of AC squared plus magnitude of CB squared must equal the magnitude of AB squared, right? Okay. Stop. Well, wait, you can't use that because that assumes what you're trying to prove. Well, I would say if it is a right angle, then I know this is true, right? So if I can prove that this is true, then I know it must be a right angle. But maybe I don't want to do that. Because, yeah, you said I was close doing the other thing.
You're not that guy, pal. Trust me. You're not that guy.
So, yeah, I'm tempted to say I'm not supposed to do that. Let's try adding these. What's up?
I don't think you can do that. Like if it was something
We don't want
like
to do this.
Or whatever. Sorry, I was in the middle of reading something else when you were saying, but whatever the stuff about if we assume it's true and then prove that it's true,
Yeah.
doesn't always work because sometimes like you have a statement like if this then that, there are cases where you can still have the output without having the input.
Sure. Oh, I see. Like that could
sense.
happen, and they could not be a right angle. It's not an if and only if.
Yeah.
Got
exactly.
you.
We can do it with contradiction, right? We can say that, okay, well, if we're gonna assume, whatever, and then if we contradict that, then it doesn't work. But if we assume that it's true, it doesn't always work.
I want to know how I'm gonna get. So I know right angles and dot products. I don't know how I'm gonna get that from this, from vector addition. Femfox says I'm close. Because basically, I got to this point, I got stuck. Okay, we're both stuck. Because I see, like, yes, I know that and that is that. I know that this and this is that. And I know that because this is a diameter, that this is twice this. Unless it could be using the angle bisector theorem. So we could say that if this is so angle is a vector CO is an angle bisector if it carves out two equal sides like this, right? Mustn't that? I think that has to bisect an angle is how that works. And then if let's not involve Pythagoras. Yeah, I don't think we want to. It's a median. Yeah, okay. It's for sure a median. I agree with that. But then yeah, wait. How can I show it's an angle bisector then? Let me think. So side. This is a side, but this is not the same angle. Ugh. Come on, Jeff.
My name is Jeff.
Jeff, channel your powers to me. Femvox says they have it. Instead, create a coordinate system where A is negative R0 and B is R0, then C is next necessarily, and then do vectors. Ew, is that really what I want to do? Jeff loves coordinate systems. No coordinates allowed.
Emotional.
Fembox says you're not allowed to use coordinates. You're not allowed to use coordinates. Okay. Let's just try like subtracting these two. Let me just subtract these two things. Let's just see what happens. I'm just curious. Maybe something will come out of it. If I subtract these, then I'm gonna get what? CO minus CB is equal to AO minus AB, right? And then AB is 2AO. So I don't know if that really helps me, because that just tells me that CO minus CB is equal to negative AO, which I think is probably what I had, right? So this CO minus CB, yeah, so CO minus CB gets me, yeah, negative AO, duh. This minus this will give me this. Femvox, I need a hint. I need a hint on this. I'm curious how I prove this is a right angle. I know from like circle theorems that if this angle is 180, that this must cover half that angle, which means it must cover 90. But I don't think that's using vector methods, right? That's using like circle theorems, which I don't think I'm allowed to use here. Femvox says so close. You're so close. Is negative AO. You let AO equal X and OC equal Y. And then I build. Okay. Okay, so let's try Femvox's method. You're gonna say AO is equal to X. So that's going this way. And then OC is equal to Y. Yeah, I don't know where the dot product is gonna come from though, is the issue. I don't know where it's gonna come from. Because I need AC and CB. So there's CB at least. I just don't know where I'm going to get dot product from, like, addition of vectors. Unless it's like the projection, maybe? I don't know. Okay. Okay. So if this is X, let's just do it for now. Let's have faith. Femvox says have faith. So I'm going to say that that's AO. And then you have it go the other way. You have that be equal to Y. Okay. So then X plus Y. Right, so X plus Y is equal to AC. And then CB... CB could be seen as, I guess, 2x. Okay, let's see. So CB here is equal to 2x minus AC, which is the same thing as X plus Y.
I think you could say X minus Y, or sorry,
X minus Y is equal to CB.
X. Yeah.
Yeah. Cool. All right, I get to there. Okay, so we got AC and we got CB. And then what's up, my love?
My man.
Oh, you're very welcome. Very welcome. Very welcome for all the help, my love. What did I help you with? I'm curious. I've helped a lot of people. Now dot those babies. Okay, let's dot them. You mean add them or... Oh, no. Oh, I see. I see. Oh, dot product means literally multiply them, right? Okay. Oh, okay. I see. Okay, wait. AC dotted with CB. That's going to be X plus Y times X minus Y. Where technically these are vectors. So this is a difference of squares, right? But maybe the direction matters. Or actually, I don't think it does, right? Dot product is commutative. So this is going to be x squared minus y squared. Right? Dot them as vectors. Well, we need components then, I think. Yes, yeah, okay, yeah, sorry, yeah. So yeah, magnitude of x squared. Yes, okay, let's do it that way. Let's do it that way. Let's be formal. So this would end up being x dot x. Let's just do the full FOIL. So minus x dot y plus y dot x minus y dot y. Let me move this over. Right, and then I can say that these two things are the same. X dot y and y dot x is the same, so those go away. And so then I have x dot x minus y dot y, which is then going to be, yes, the magnitude of x squared minus the magnitude of y squared. Okay. Oh, and they're radii. Oh, this is so crazy. Oh, I didn't even notice that. The last little bit there. Yes, these are both radii. Oh, that's okay. That's the clever part I was missing. But x and y are both radii. So, yeah, the magnitude of x squared equals the magnitude of y squared, which you could say is just equal to r squared. So AC dot CB is equal to 0. Wow, very cool. Yeah, very cool. And then you're done. Yeah, okay. That's cool. Very cool question. Oh, yeah, this is actually cool. Yeah. So, yeah, I didn't see it. Yeah, I should have. I'm a little upset at myself. I didn't notice that this and this are both radiuses. Or radii, sorry. So, yeah, duh. But, and then this is also... Yes, and x squared, yeah, minus y squared is yeah, so it's 90. Yeah. Well, also, no, I think this is kind of the main thing. We wanted to show that AC dot CB was equal to 0. Yeah. Which we just did here. Yeah. And angle ACB is 90 degrees. Cool. Great question. Yeah, that's cool. I'll look for that next time. I should have seen that they were radii, and then that played an effect. I like these questions, Gladiator, because it forces me to try to think about things just using vector algebra, like vector calculations. Is pretty cool. Yeah, very cool. All right, let's mark that one as done. There we go. Who needs those sines and cosines?
My name is Jeff.
Jeff does. Jeff loves them. Jeff loves things. It's like, put it in a coordinate system.
All you really need is Kosh and Cinch.
That's right. Yeah, listen to Breasticles. All we need the hyperbolic trig functions.
Yes. That's all we need.
All right, let's go see what's on the queue. All right, so we got some cool ones. So, oh wow, discrete math, electrical engineering, chemistry, more electrical engineering. If it's so, yeah, 6 out of 10 I might be able to do for electrical engineering. Yeah, oh, because this is register shifts. This is kind of cool. that's cool. I haven't thought about this. But then some of this other stuff might be a little trickier. What is this? Yeah, a discrete time invariant digital. Oh dear. Yeah. This is a little bit outside my wheelhouse. Yeah, but it's okay. All right, let's see who the winner is. Yeah, how this works is the more time you have in the queue, the more likely your question is to be picked. You can also click the upvote button every 3 minutes. And also the rate at which your question gains votes is a little dependent on the difficulty and like the grade level. We're trying a new thing where we're starting to favor kind of more of the high school level questions to not scare off too many of the high school kids with discrete mathematics. But I still want there to be a chance that we will do it. So that's how this works.
Discrete's not that scary.
Maybe it's not.
Well, that one's.
This one might be scary.
I'd have to take a look, but normally it's not terrible.
All right, let's spin for winners.
Let's go gambling!
And it's you, Best Goals. Yeah. Yes, Blue, people do still have questions from school. Because as I was saying, California high school doesn't end until probably, I think, June 15th or June 20th or something. But in the South, right, yeah, in Texas, I think high school's basically done at this point. Or like next week. All right, let's see. What do you got for your Best Goals? An idealized muzzle blast pressure wave. Speaking of Texas and guns.
It's very Texan.
This is very Texas. Okay. A gun fires and the pressure disturbance in front of it is a one-dimensional nonlinear acoustic wave. Cool. Acoustic overpressure where X is distance from the muzzle and T is after time firing. Assume the wave satisfies the nonlinear transport equation.
Yeah, it's also called the shock wave equation. Even though
The shock wave equation.
not necessarily a wave, it's a transport equation, and stuff gets transferred with part of the shock. But
So we're like surfing the wave. Okay.
yeah, exactly. That's easiest to think about, like when a wave crashes down.
Mm-hmm.
That's what we would describe as like a shock wave or
Gotcha.
a shock in a system. It's any sort of like discontinuity.
And then we got initial pressure profile where, okay, so it's a decreasing exponential at time t equals 0. And yes, the pressure strongest at the muzzle and decays as it's further away. And then I would also assume that the peak moves away as a function of time, which I think, is that what we're going to see for the characteristic solution?
Mm-hmm. Yeah, we'll see how it, basically what'll happen is our function will like behave along this characteristic equation in a certain way, and then you'll see some sort of like crash or drop in pressure, or sometimes it's a rise depending on how your equation is set up. You'll see a sudden change in the system.
Cool. All right. So yeah, let's try to solve it. This looks kind of non-linear because I got partial p partial t, I got partial p partial x, and then I have p as well, just like chilling in there. I don't think I've ever seen this before.
Yeah, that's the 1 plus p right there is what makes
that's what messes it up, right?
Yeah. So if we just had p of t and plus p of x equal to 0, that would just be our standard transport equation. It's linear. It's not too bad to solve.
Oh yeah, that's just the wave equation
method. No, it's kind of part of it, but not entirely.
But this is like messing things up.
That
Yeah,
gives us a couple of problems.
Okay. All right. How do we start this?
Okay, so we're gonna start by setting up our characteristic equations. So we're gonna want to say that dx dt is equal to 1 plus p, and dp
dx dt.
Yeah.
Like this?
Full derivatives.
Full derivatives, not partials.
Yeah, because we're getting it from our idea of a total derivative. So we would say that our partial p partial t multiplied by our full what's it called?
Full derivative?
Yeah, I'm blanking. My English isn't working. But yeah, we're getting that from the exact derivative.
So where does this come from? First of all, that dx dt is equal to 1 plus p.
Yeah, me.
Yeah, that seems like we just pulled it out of the hat.
Photo.
Well, like, where did this just come from?
Here.
You got fried on the identities test? Oh no, 1K. You tried just converting everything to sine and cosine? That's the way to do it. Or caution cinch if you're breasticles.
Yeah, it comes from that. From our exact differential.
Okay, let me pull it in. There we go. Copy. The identity was half a page. Oh, can you send it so I can see it? I'm very curious to see what it would have been. Okay. A differential of this form, df is equal to p xy dx plus q xy dy, is exact if integral of df is path independent. This will be true if df is partial f partial x dx plus partial f partial y dy. So p and q must be of the form that and that. Okay.
Yeah, and so that's where that comes from. You'll see like differential equations like that in normal ODEs as exact differential equations, and then similarly here we're getting it from saying, okay, well, df is 0. Partial f partial x is right there, so our dx would be 1.
Oh, I see. You're saying this is df. Oh wait,
yeah.
wait. I see. Okay, sorry. So this is df. Ooh, where's the dx and the dy coming from though?
That's what we're trying to figure out. See how we have our partial f partial x in this case, right? It's
Yeah.
p, but we have partial f partial x. So that would mean that.
Oh, so that this is now dx.
Yeah, that would have to be dx.
Oh, okay. I see. So you're having it look like this. And you're saying, oh, wow. Well, wait. Partial f partial x, that's here. So then this must be equal to dx. And then this is partial f partial y. So then dy is equal to 0. Or dy is equal to 1.
Mm-hmm.
Okay. So then, oh, I see. So, what is that? So dx over dx over dy is equal to 1 plus t. Where did we get dt from? Sorry. Oh wait, no. Yeah, t is y. Okay. Sorry, I see it now. I see it.
Yeah.
Okay.
dx dt, and then we say that dt equals 0.
Okay, got you. Okay, so, yeah, I see. That's too funny. You're just saying, oh, it just looks like that. I would have never thought to say, oh, this must be df.
Yeah, it's kind of a.
You have to
weird.
just recognize that. That's crazy.
We're in essence looking at it and saying, well, it's exact. It's technically an exact differential equation.
Yeah.
And we're just recognizing how we can.
It's so funny because that's how so much of DiffyQ is. Whenever I think about like teaching DiffyQ is really a lot of pattern recognition. It's a lot of like seeing a differential equation and knowing it looks like something of this form, and this is the strategy we have for solving it.
Yeah,
which makes me wonder, like, how the fuck did people come up with the strategies in the first place?
Not good.
People just
there's a lot of like
tripping balls, just like figuring things out. They're just like, well, this kind of looks like this. What if we tried this?
Yeah, I mean, and there's also just like some. Like a lot of recognition, you got to be able to. A lot of what like helped me with DiffyQ was actually understanding what I'm doing with a differential equation. So understanding, right, rather than just looking at something
memorizing.
Like
It's just mechanical.
Equation, and being like, oh, I remember this is going to be sines and cosines. actually being able to recognize, like, okay, what this equation, is saying that, the concavity or the derivative or the jerk of the equation or whatever it may be is directly proportional to something else. And then, okay, there's a forcing term, and that's going to do this,
and
or
then
that's going to do that.
and this is stable or whatnot. Yeah.
Mhm.
Yeah. Okay, so we got dx dt is equal to 1 plus p.
Then we're also going to need that dp dt is equal to 0.
Okay, partial or full?
Awful.
Okay. Where is that one coming from? dp dt is equal to 0.
From the 0 on the right hand side, because our f would be p in this case.
Ooh, okay. Wait, our f would be p. Yes, okay. Okay, right, yeah, okay. So
Yeah, and we just expand to get the dt on the bottom using the chain rule.
got you. Okay, I see. Okay, all right, dp dt is 0. So do I take a second derivative of this?
No, we wouldn't.
No,
need to
because
do
that would just be 0 anyways,
we're
too.
Oh shit, not good.
Yeah, we're
Really
gonna
helps out.
we're gonna do your favorite letter of all time, not alpha, xi, the squiggly
Oh.
one.
This one, I hate this one.
Yeah.
I hate this symbol.
So the characteristics start at 0, so we're gonna say that x of 0 is equal to xi.
Okay, x of 0 is equal to psi.
And then p of xi comma 0 is equal to e to the negative xi from our initial conditions.
Yes. Okay, cool. Sure.
And then because the idea of the method of characteristics is that we're looking at these characteristic curves where our p is going to be constant. So we can say that along the characteristic lines, p is going to be equal to e to the negative xi.
Okay, so along the curves, p of psi of 0 is just equal to e to the negative xi. Yeah.
Yeah, we can just say p is equal to negative xi.
E to the negative xi. Yeah.
Yeah.
Okay, cool. And that's at time equals 0. Okay, sure.
All right. And now we can substitute back into our dx dt equation.
Okay.
had.
So
Right, because we know that p is e to the negative xi, so we can put it in there.
cool.
All right, and then since e to the negative xi is constant along the curves, we can just move t over to the other side and then integrate.
Oh, this is my favorite thing. I love doing this. I love let's just move this shit over here. Okay, fine.
By the chain rule that we
by the
won't
chain
write
rule.
the steps out because it's too much work.
Okay, so then this is dt. And then I'm going to integrate both sides.
Mhm.
So are we going to go from 0 to t and then 0 to x? Or are we going to leave a plus c
Or it would
and
just
then
be,
eventually figure it out?
it would be indefinite,
Okay.
and we would just say plus c.
Okay, so then this is going to be x is equal to t. But wait, is xi a function of t?
No, xi
No.
is just a function of x. So what we can do is just leave our 1 plus e to the negative xi as a constant, multiply it by t, and then just add another xi.
Okay. So you're going to say 1 plus e to the negative xi t,
Mhm.
and then we're going to put another xi in there.
Yeah, we're gonna do plus xi because the idea is we're technically like partially integrating in the sense there's gonna be a
Partial
constant.
integration? Oh, man.
Yeah,
What?
yeah, because we're integrating with respect to t.
Yeah.
But there's still a element of x that could be in there that we're not accounting for.
Mm-hmm.
And since xi is x of whatever, or x of 0, we can just call that
Okay. And then is there still a plus
our
c here?
constant. No, that's our constant.
That
so
is the
to speak.
constant. Oh, right. Because x of 0 is equal to xi. Okay, got you.
Yeah.
So, okay, this is a constant with respect to t. Okay. Right, and then this is now c because x of 0 needed to be equal to psi. Okay.
And now we can just start working with our initial conditions and do some physical interpretation.
Okay, our initial condition was p of x 0.
Well, I guess,
Oh,
yeah,
oh,
it's not like explicitly necessarily stated, but so we're gonna start by looking at p of 0, 0, right?
Okay.
So at the initial pressure at the muzzle.
okay, so this is, yeah, initial pressure at, or not, yeah, this. Now wait, and this equation here just tells me what x is. This doesn't tell me what the pressure is, right?
Yeah, but we should be able to solve for that.
Okay. All right, let's try to do it. Okay. So p of 0, 0. So that's when t is equal to 0, right? Oh wait,
yeah,
wait.
and
Okay.
it's just gonna be 1. Just at 0, we're just gonna say it's 1.
Okay. Oh, from here. Oh, wait. Where did I have that? I had from dx dt is equal to 1 plus p, or where am I? Sorry, where am I getting that from? Okay.
Yes, I believe so.
Wait. What happened to p? P was that? Oh, p is equal to e to this. Okay, this was the other thing.
Yeah.
Okay, there we go. This is what I wanted. Okay. So p of 0, 0 is just equal to 1. Okay.
Yeah.
This has no time dependence on it though.
Yeah, we're looking at it. So along the characteristic curve, it's just constant. So we know that along these specific curves, p is going to be equal to e to the negative xi.
Got you. Okay.
And then as it evolves, it basically will just kind of look like moving discontinuities. But
It'll just
along
hop to another curve, you think?
Yeah, in essence, yeah, that's normally how it looks.
Okay, so initial pressure at the muzzle is equal to 1. What about can we use this to figure out where it is further away?
Yeah. So we're gonna go, and then we're gonna first figure out the characteristic speed.
Okay.
Which is just 1 plus p is equal to 2.
Okay, so let me say, what about the
So-
speed? Which that would be dp dt, no? Right? Wouldn't that be the speed of the pressure, or is that dx dt? Oh no.
It would be
no.
dx dt because we're talking spatially.
dx dt, right, good, is equal to 1 plus p. So that's equal to 1 plus 1, which is equal to 2. Okay. Cool. All right. What do we do next then?
All right, and then so here's where it gets kind of like physicsy. I think you'll like. Basically, we're gonna pretty much just say that for large values of xi, the pressure gets smaller and goes to 0.
Okay, so for xi is greater than 1, the pressure decreases. Okay.
Not necessarily for xi greater than 1 for any large value of xi, right? Because as xi goes to infinity, it's
Yeah.
going to approach 0.
Right. Well, yeah, p is equal to e to the negative xi will approach 0.
Mhm.
Well, yeah, okay, sure.
Right, and then so when we go look at our dx dt being 1
Mhm.
plus p, we're going to get that 1 plus p is approximately equal to 1.
At large values of xi.
Yes.
Okay, so 1 plus p is equal to 1. So dxdt has to go from 2 to 1?
Yeah, and that's why the shock forms. What actually it was Pineapple that like inspired this question.
Uh-huh.
Because they asked me a question and it was about like real life examples of discontinuity, and the reason I thought of guns is they're a great example because they actually have two shock waves. There's
Okay.
the muzzle blast, because if you think about the way it works is it builds up pressure inside of the
barrel,
the
yeah.
shell, and then that gas keeps expanding and building pressure behind the bullet all up until it leaves the barrel. There's first that initial shock of all of that, or kind of there's other ways that it combusts and how the gas moves through the system, but there's, for the most part, there's that very sudden expansion of gas, which is a pressure shock. But also on anything moving supersonic, there's a second shock that comes from the bullet itself moving past the speed of sound.
Ah, okay.
That creates a distinct crack, and so there's two pressure shocks, and it's there's a lot of different ways you can go with it about, like, you know, fluid dynamics and shock interactions and shock wave equations and all that. And so that's what that shock is that fact that it goes from 2 to 1, is there's a sudden discontinuity in the equation, and so, or in the function, and that's the high pressure part of the wave moving faster than the low pressure part of the wave in front of it.
I like to also think about, I mean,
like,
this is kind of the supersonic pressure.
Yeah, that's what happens at supersonic, and I think I want to say it's a rather similar cone for the muzzle blast as well.
Mm-hmm.
But yeah, for supersonic, it creates that Mach cone, which is always pretty cool to think about.
And then if anyone is, like, for instance, just like chilling here on the ground, they feel this like huge wave front of sound just like hit them. I used to think that a sonic boom only happened once, right when something crosses the sound barrier, but actually apparently a sonic boom is happening continuously, but it's only being heard once at every location because that wave is moving.
Yeah, exactly. It's basically like one big, like, pressure front, like discontinuity.
Yeah.
Barreling with it, and then
it's super cool how it happens.
One.
And this is kind of a, let me see if I have like a Doppler shift animation of like why this is. It's got to be like something cool. Yeah, here we go. Is it? Yeah, love you, flipping physics. Yeah, so this is right as something is like moving towards an observer, the waves it's generating are spreading out more behind it, and they're compressing more as you're going into it. But then in the case of the Mach cone, so for instance, this circle was generated from the object when it was here, and that radiates outwards at a velocity equal, they call it like c, is like the speed of sound. And then that speed of sound times the amount of time is how this thing like evolves outwards. But then at, let's say, for instance, this point, that forms this circle. And then this one, whatever the center of this one, forms this circle. This one forms this one. This one forms this one. And then the cool thing is that the sound generated is all then hitting this like same spatial like front at a certain at the same time, and that's why you get this huge constructive interference, and that's why you hear like a huge sonic boom. But cool. Okay.
It is. It's very cool.
It's very cool. It's funny that you bring this up because I was just teaching this to a student like last week, and actually honestly reteaching myself because I forgot how like sonic booms happen.
Yeah, I did too. It took me a minute. I was like, sonic booms, when I thought of like a discontinuity, I knew that, but I was like,
Yeah.
I didn't remember a lot. I had to remind myself.
Yeah, I had to too. Okay, cool.
And then
So, well, go on. You're good.
Oh, I was gonna say, and then I got on a lot of tangents and things me reading, like
Tangents and sines and cosines.
Oh no.
I made that
it
joke.
was just, I was thinking it's cool. I was thinking about how like a suppressor works with the baffles. When I was talking about like that discontinuity at the muzzle, I was like, wait, is that how a suppressor works? And this is when like chat gets really helpful, because instead of going to Google and searching through Google and web pages and all that to see if I'm correct, I was just like, hey chat, is this how it works? Is this why they're engineered that way? And it was like, yeah, you're right. Because they designed the baffles to slow the release of the gas and the pressure so that there's not an instant
There's not a whole
shock in
front.
the
Yeah.
system, So it slowly releases gas rather than allowing
Letting it all hit at once.
pressure front to hit at once. Yeah,
Okay.
which is
Cool.
very cool to think about.
Okay, nice. Is that it? Did we figure it all out?
Almost. We just gotta real
What's
quickly,
the last
since
part?
we're still in terms of xi.
Yeah.
Since we said p is equal to e to the negative xi, we're just gonna say that xi is equal to negative ln of p, just by our natural log properties.
Okay. Sure.
And then we'll want to plug that
Exponentiate
back
both
in
sides?
for. Oh no, we're gonna plug xi in our equation for x that we got.
Oh, okay. We're gonna plug it into here.
Yeah.
Okay. So then we get that x is equal to, well, 1 plus. Wait, isn't that just gonna be 1 plus p again? Is that just 1 plus p times t?
Oh, it'd be negative ln of p plus 1 plus p,
P
times t.
Yeah. Good. Okay. Cool. Okay.
Or we could also, just by moving around our equation for xi, also get that p of x comma t is equal to negative of all of it minus well, I guess it is negative of all of it, x minus 1 plus p times t.
X plus p times t, or 1 plus p. Sorry.
X minus 1 plus p times t.
1 plus p times t, like that. Nice. And yeah, that's I see the exponential. It decreases both in space and time. And then yeah, there's kind of a shift. It's crazy that p's also in it as well, though. That's what makes it kind of weird,
It
right?
gets funky, and that's why
it's like recursive.
kind of, it's non-linear. Yeah, when you look at the actual, like, a graph of what this would look like, there would be a bunch of shocks where it has discontinuities. So like this would have a shock at 2,1 as the first shock, so it would kind of grow or decay and then suddenly change, and then grow or decay and then suddenly change again.
Gotcha. Yeah, shock at 2,1. Oh wow, yeah, I see how that works. Okay, cool. Nice, cool question, Rascals. I thought it was fun. I learned some stuff. And shockwaves are dope.
Yes, they are. See, I don't think that was like an 8 out of 10. There was some stuff good.
Give it like a 7. I think I'd give it like a 7. 7.
Yeah.
Give it a 7. Nice. Oh, flipping physics? Yeah, dude, he is goated. Yeah, Jonathan, he's a real cool guy. I've had meetings with him before, years ago when we were talking about like AP curriculum stuff. We borrowed some of his like cheat sheet, review sheet stuff to integrate it into one of the AP courses I was running. He's pretty. That was before he was even at 100,000. I think he just hit 200,000 subscribers on YouTube. So I've tried to get him actually on my stream here as like a podcast guest, and he politely declined. I should have tried it when he was probably before he was bigger. I understand that now he kind of probably has a reputation and whatever thing to uphold, but he's a cool guy. He's a cool guy. I like what he does. He does a lot of good things for people. And he puts out a ton of content. Because that's his like full-time job now. Alright, let's go see what else we got for other questions coming up. Lucky Cat Equity, hello, Yoda, Noob, Nitro, and Wad. 4 out of 10. This one looks like kind of nice. Although I don't know if that's a 4 out of 10, but we'll see. Alright, let's see. Lucky Cat, let's see if you get it. You have a 41% chance of winning.
Let's go gambling!
And it is you, Lucky Cat. You're lucky today. Lucky today, Lucky Cat. Nice. Ooh, good. I like this. This is a good question. This is Trig. Okay, this is a sinusoidal. We wanted to determine an equation showing how you determined each parameter. So it turns out you could actually have a couple different sinusoidals that would describe this. Actually, technically infinite number of sinusoidals. But I think we're going to go with the easiest one, which is just sine. So the generic form for a oscillating function like this is y is equal to a. And then we would say sine of, let's say, I think I want to say ax. I forget how I want this to go. I forget if I put the parentheses around it or not. I'm gonna do this. I think I want to do this. I'm gonna say ax plus b. Or well, here we shouldn't have too many of these same letters. Sorry. B. I'm gonna say x plus c, and then plus d. I think that's kind of the. I always forget whether I want to group this in the parentheses or not. But I'm pretty sure this is correct. Yes, thank you, Shaq. Everyone have a great day and gain knowledge today. I appreciate the bits. Thank you. Okay, amplitude. So I think the easiest one actually to usually find is either amplitude, which is this, or the midline, which is D. So let's use the amplitude first. This one's kind of nice. So A is equal to the amplitude. And this is 1/2 the distance from the top to the bottom. So we'd say 1/2 peak to peak, maybe. Or peak to valley. You guys like peak to valley? I think it's kind of a fun one. So you want to see, like, what's the highest this value can be, and, like, what's the lowest it can be. So the highest it can be right now is 5. Yeah, peak to peak is period, correct, yeah. So peak to valley, so this is going to be equal to 1/2, and then that's going to be 5 minus 1. Or, you know, let's not do peak to valley because that's kind of like weird. Let's just do 1/2 of max minus min. I think this is kind of the easiest way to do it. That's probably the easiest way, right? So this is going to be equal to 3. That's the amplitude. D is the midline, and the midline is the average of the max and min. So that's going to be equal to 1/2 of max plus min. And so, what's that? That's going to be 5 minus 1, which is 4. And then divided by 2 is going to be 2. We're going to say 5 minus 1 divided by 2, which is going to be 2. Okay. 1 sec. I got to grab something from my front door. I will be back in like 3 minutes. I have a package I've been waiting for. Let me put my... Where's my we're right back thing? We'll be right back. Hold that thought. Okay, there we go. When am I doing the giveaway? We did the giveaway 1K. We did it earlier today. I did it at the beginning of the stream. Okay, sorry, I had to go sign for a package. I've been waiting for a while. All right, let's see. Let's go back to this question. All right, so D is the midline. That's going to be averaging those two. So that's equal to 2. Okay, then B is called the period, which is going to be equal to 2 pi divided by the peak-to-peak distance. And this is kind of like the x distance. All right. So peak to peak is from here to here, as Jeff said.
My name is Jeff.
Yeah, that's peak to peak. It's for period. Okay. And so that's going to be 4 pi over 3 minus pi over 3. So that's going to be 3 pi over 3, which is pi. All right, so we just got 2 pi over pi. So that answer is just equal to 2. Bye, Arya. Good to see you, Arya. Our resident Maddox champion. Mental math expert extraordinaire. Okay, I think that's good. All right, and then the last thing we have to do is the phase shift. This one's kind of the hardest one. C is going to be the phase shift. So, and then I think, actually, usually we don't want to do plus C. I think you usually want to do minus C in this case. Solve the JEE. We don't like JEE.
Oh no.
Please don't do that to me. Okay, so the midline was at 2. Let's kind of just draw where that is. There we go. This is the midline. And let's think like where sine usually starts. Sine looks like this. So I want to know like where this point is here. Usually it would be at 0, 0, but we have it shifted up by some amount D, and it's also been shifted to the right by a certain amount. So this is where it should be. It should be here, but it's actually located here. So we want to know how much has that been shifted off from the x equals 0 position that it was supposed to be at. So if this is pi over 3, and then let me see how this is broken up into 1, 2, 3, 4 into 4 divisions. So that means that this must be pi over 12, right? Because then this would be 2 pi over 12, which is pi over 6. And pi over 6 is halfway between 0 and pi over 3. And yeah, that shift is to the right. So that's why this is going to be a minus something. All right, so if we remember from like doing transformations of functions, right? If you do like x minus a, that moves it to the right. And then like x plus a moves it to the left. So this is going to be a phase shift of pi over 12. Yeah, okay, cool. So there you go. So here your final equation will be y is equal to 3 sine of 2 x minus pi over 12, all in parentheses like that. And then you're going to say plus 2. And there you go. That's it, Lucky Cat. Hope that makes sense. You're doing the same thing right now? Oh, very cool. 1K. Yeah. I have a whole series of videos on these ones. So this is how like you take the graph and you create the equation. I also have one on like how you take the equation and create the graph. So if you want to check out that one, it's under, if you go to like our YouTube channel, go to search. And you can type in like sinusoidal. And then there it is. Here's a bunch of videos on like how to graph sinusoidals. So here's like the complete guide. Our first one, dude, has 115,000
So a lot of
views on
times
it.
you'll be.
This is huge, actually, yeah. And I put this video out 2 years ago.
Takes you 4 parts to type desmos.com in the search bar.
Oh, you don't always get Desmos in the classroom, though. You know, that's the problem.
At this point, yeah, I give it like 2 years, and you will. I mean, they got it on the SATs now.
That is crazy, yeah. The fact that
I
they have
remember
Desmos on the
and-
SAT is nuts.
I guess Calc now is like a mixed exam too.
Yeah. I think AP
Which is-
Physics, they get Desmos.
That's diabolical.
It is
I
diabolical.
remember like AP Physics are like, yeah, set up this differential equation for Kirchhoff's laws, and we're all like, what the fuck?
Yeah, just kind of leave it. I mean, I get it. It's cool to be able to like use those tools, and I agree at the upper level classes, it's annoying to waste time having to solve a systems of equations when you can be like, just graph the two things and find the intersection, right? So I'm cool with that for like Desmos. I still think there is some importance in understanding how to graph sinusoidals by hand, so that you at least understand what parameters do what things to the shape.
Yeah, I agree. I don't really, honestly, I don't think they need Desmos and that type of stuff. I feel like at the point when a system of equations is gonna take a calc student that long, they either should really study up on their systems of equations, or like they need to be able to make
Do it
better
quicker.
questions on they need to make better questions on the exam side. Because just like I could give you a 20-minute question that's
Yeah.
difficult calculus stuff that's actually like conceptually challenging, on the same merit you could give anyone a question that challenges anyone by making them solve, the determinant of an 8x8 matrix.
Yeah,
But
which
you're
would be
not
gross.
really
We're not testing for
developing
that.
any understanding doing that. You're just
Yeah.
making it hell.
I just think some of the quadratics are really ugly, especially when they don't factor and stuff. It's just like, man, it's. I guess it's more lazy. I don't want to plug in like x equals negative b plus or minus square root, blah blah blah. I'm just like, yo, just give me the roots, dude.
Just do it. Yeah. That's
Just give me the roots.
understandable.
Just give me the fucking roots.
Are you guys doing more Physics 1 and Calc 3 kind of things right now?
You can ask one if you want. Yeah, you can ask. Nathan's like, I want knowledge. I want to learn stuff for just having the fun of learning now, that I don't have to do it for class.
It's also so I don't struggle.
That is true. Well, you know what? If you know what class you're going to take next, you can. Well, first of all, if you're taking what physics, like undergrad physics 1, or what is it?
Mechanics, yeah.
Yeah, perfect.
Physics.
Yeah.
For college,
Here, do you have a textbook yet, or I can send you a textbook?
I don't have a textbook. Oh, actually, I have a textbook for physics, but I don't have a textbook for math yet. I'm not sure what we're going to be using for math. So I guess I kind of just use my old one, since the old one also has Calc 3 stuff.
It's probably going to be either an e-textbook or whatever your professor wrote.
Yeah, the
Yeah, I think
professor. The worst when they do that.
I think it already has Calc 3 stuff.
Yeah. Well, you can if you already have here. I'm DMing you like some physics textbooks.
Well,
But-
hell yeah.
If you already have so with the physics stuff here, that's the equation. That's the full book and also the solutions manual. But so you can like start just going through the first couple questions of that and just like pick the ones in the back that don't make sense, and I can teach it. Or
Nice.
the same thing with the calc stuff. If you already know that like, oh, this stuff has calc 3 on it, just pull out like some beginning like calc 3 stuff.
Yeah. What? By the way, I have a question. What mouse do you use for your MacBook?
I don't use a mouse. I use a trackpad for my laptop.
Actually-
Yeah, I don't use a mouse. I just use a trackpad.
Oh man, I kind of want to use a mouse so I can write on like a notepad or something, you know?
Oh, I mean, I use this. I mean, I use a. Are you talking about this for my mouse? Like my
Oh,
stylus?
that would be fire.
This
that would
this
be
is how
fire.
this is how I write everything. Like everything we do on the stream here is because I have a stylus.
Oh wow, I'm used to using my mouse. I've never
No.
seen it. That's cool.
Oh my god, that would be painful, dude.
I've gotten used to this. I'm really good at it.
Really? No, dude. Oh my
Yeah.
god. I like Wacom. I think this is the one I use. Yeah, the Intuos. Yeah, this is the one I use.
Oh wow.
It's Bluetooth. It's solid. It just fucking works. You can go onto Amazon and get cheaper ones. I've had those before. They just end up dying after like a year or two. The Wacom is just bulletproof.
That's sick.
So yeah, tablet. I don't use that to play games. I guess I could technically like play shooter games with this. What is it called? It's called like writing tablet, maybe. I don't know if I can call it.
Oh, this is a Calculus 2 book.
That's it has a little bit of Calc 3 in it as well, though.
Oh yeah, you're right. Yeah.
So towards the end,
I
yeah.
see.
If you want to see there
Yeah,
is
yeah.
some.
I threw a basic Calc 3 type
Okay.
question.
He threw one in for you.
For Tuma as well.
Oh hell yeah. Thank you.
There you
Thank
go.
you.
There, it's a difficulty 5 out of 10.
Whoa.
I wouldn't
Too
call
much.
it a 5. I think it just thinks it's because it's multivariable calc, but it's just
What is it? What is it? What is it?
the partial derivatives.
What's this? Yeah, it says grade level 13. Yeah. Dude, this
Like
says
electrical
Coach.
engineering stuff.
There are a lot. Yeah, I'm not sure I'll be able to do the electrical engineering questions. One of them doesn't look too bad, but the other one, yeah, I'm just like no. All right, let's spin the wheel, see who's gonna get picked for the next one.
Let's go gambling!
Rusticles, rusticles,
It was close.
It's electrical engineering, so
I might be able to do this. I don't know about like
Sure.
design a ripple counter. I don't know what this is.
yeah, I know I've done register shifting, but
Yeah.
I don't know if I've done it with the serial input. I know about like logical right shift and logical left shift and arithmetic left and right, but not necessarily.
With the serial input being
Serial.
that, what is the content of the register after sorry, what does this even mean? I know what this number is in binary, right? What is this? This is 0, 1, 1, 0. So this is like 2 to the 0. This is 2 to the 1. This is 2 to the 2. So that's a value of 5 in decimal. But then they say it's shifted 6 times to the right with the serial input. So wait, oh, are there 6 numbers here? 1, 2, 3, 4.
No,
5.
that was what was throwing me off.
Wait, now there's 7 numbers.
Yeah.
Excuse me? Wait, what? How does this work? Ooh. Serial
Whoa,
usually means
what is
in
this
line.
stuff?
This is electrical engineering. You understand binary, Tuma, right? Do you understand binary?
Yeah, I know how to like. Okay, so the first one's like 1, right? Or like, and the second one's 2, and then 4, and then 8, right? 16,
Yeah.
32.
Yeah. Also, your mic is so much better today. What happened? What happened?
Yeah.
How'd-
Oh yeah, did I tell you? I got the
No.
MacBook Neo.
Oh, nice! You're on the Neo right now.
Yeah, yeah.
Yeah, you told me you were gonna go out and get it. Oh, dude, this sounds like so much better, dude. Oh my god, it's like Tuma HD, dude.
It's
What the
so
hell?
fire. It's everything is clean about it.
What color did you get?
I got the citrus. I know it's not popular, but it stands out the most.
Let's see, MacBook. Yeah, we were talking about laptops earlier today, and I was saying like, yeah, I've had Mac. Oh, I do like the citrus. Oh, that's a fun color.
Yeah, it's so cool, dude. It looks like gold whenever it's like under light.
Oh hell yeah, dude. Maybe I need one of these now. Just as like a fun
like-
one to just have.
Oh my god, it's so like the thing is it's budget friendly, but it's so good. I
Yeah.
can like run Cyberpunk or Minecraft on it.
Wow.
Yeah.
Yeah, I never use my Mac for gaming and stuff, but that's cool that it's able to these days. It's yeah.
The cheapest, he said the cost for it. The cheapest for it is 500, I think.
Yeah,
Because if you get the educational discount, then you can get $100 off.
yeah. They knock 100 off of it. Yeah, yeah. It's super good. I recommend it to people for like a starter laptop. It's great. Also, it runs like basically like the old iPhone chips is what it does. So it's like super efficient
Yeah.
as well. Yeah.
It's so amazing. I like it.
All right, let's see. Great. I'm glad you got it. The mic is so much better on it. Oh my god. I can hear
Oh
you.
yeah.
Yeah, you use that in college? Yeah, exactly. Yeah. I always Mac, as much as I hate iPhones and Apple for being like their walled garden is like really annoying. They do make phenomenal laptop hardware. Some of the best. My PC laptops would last maybe a year or two, maybe 3 before they would just like combust and like break. But my MacBooks have all lasted 7 years, like if not more.
Hell
So
I've
it's worth
had
it.
pretty good experience with the Surface, but they like in the past couple of years have just
The Microsoft Surface?
amped up the price. Yeah, they've just like keep amping up the price. on
Aren't
it.
those the ones that broke on the Artemis like launch though?
I'm not sure. To be fair, normally I don't know about your computers, but I
Yeah.
don't usually like care if my computers can handle several Gs, but
I have the
I'm not
Surface Pro
sure.
7.
They work. Yeah, I mean they work great, especially for like when if I need to do actual typing and then I need to like handwrite. But
But my Surface
price
Pro
is
7 is so laggy.
Yeah.
mine works
That's
pretty well.
yeah.
My only issue that I've had is that sometimes when it's on the charger and the screen starts getting really hot,
Oh, now I hear you double.
like your hand starts sweating, it gets kind of rough.
Oh,
It
one
doesn't
second.
like pick up all of your inputs.
Tuma, why do I hear my audio through your thing? Oh no, it's breaking.
You're not that guy. pal.
Not the
Trust me.
MacBook Pro.
You're not that guy.
Oh, there he goes. It's better.
No, I switched it to Studio, but let me change it back to custom.
Yeah, it's Studio. What's Studio? Like some like mode
It's
or
like a
something?
different input.
Yeah, don't do that. Okay, here we go.
Yeah, I don't know.
If you're going to the moon, it's better if the mundane stuff break. True. All right, let's see. So for a right shift, every bit moves one position to the right. The rightmost bit falls off, and the new serial input enters from the left. Okay. So this is your initial thing. This is the serial input coming in. Oh, and so this is kind of the trick, is that the register was only shifted 6 times, so you only use the first 6 input bits.
I see. That's kind of what I figured. I wasn't sure.
Wait, but it comes in from left. You read this one from left to right? I thought usually you read from right to left on like doubly stuff.
It depends on if you're right shifting or left shifting. So there's generally the first type of shifting you'll see would be in like a basic like computer architecture type class.
Mm-hmm.
So you'll have your logical right shift, your arithmetic right shift, and then your what's it called?
What's the difference between a logical right shift and an arithmetic right shift?
Yeah, I just realized. Sorry, it should be there's a logical left shift and an arithmetic left shift, but just a normal arithmetic right shift.
Okay.
Actually, no, sorry, maybe I'm mixing those up. Point being, it's basically one of them. Your arithmetic will keep your actual value, right?
Mhm.
So yeah, so it'd be a right shift if you're doing an arithmetic, because you would copy your sign bit when you have a signed
Oh, a signed integer, yeah.
binary number. Yeah, so the far left digit
is what
keeps
says
this
whether it's
value.
negative or not, I think, right?
Yeah, so like for the 0110, if that were a signed four-digit number,
Yeah.
right now it's equal to it's 1, 2, 6. Yeah, it's equal to 6.
Uh-huh.
If that digit on the left was a 1, that left digit would be equal to -8.
Yes.
And then
Yeah, it does like the
so it
converse
would-
of it. Or the
Yeah,
inverse or whatever,
and
yeah.
so in an arithmetic shift, you would copy that sign bit to make sure that the actual value of your binary number stays the same.
Mhm.
Whereas in a logical shift, you would just add zeros in.
Yeah, I see. Because it's just like true or false.
And so,
I get it.
if you're shifting it right, you're actually bringing everything in from the left.
Mm-hmm. Okay, so this is the register, and then so we're doing a right shift. So this one like leaves, And then whatever came in from the serial input, which is apparently reading from left to right, that then comes in. So this is funny. Yeah, so this leaves, but then the 1 enters. And so that's why you have 1, 0, 1, 1. Then the 1 leaves, and then the 0 enters. So that's there. And then you just go so forth and so forth, and then eventually you get to here. Okay. That one's not so bad. It was tricky that they said it was going to be shifted 6 times to the right, and then the serial input was a 7-digit thing. I was like, wait, what? These ones are probably a little harder. Design a ripple counter for BCD. I don't know what that means. To count in decimal from 0 to 99. Design the decade BCD, and then design the ripple to count. I'm just going to look at this on chat. I'm just curious what it is, but I don't think we're actually going to answer it. This is like some more advanced EE stuff that I've never really even seen. What's up, Hypersonic? Thank you. I do need drink water. Let's see. Okay, a BCD ripple counter counts 1 decimal digit using 4 flip-flops, but it only uses the binary states 000 to 1001. Yo, what? Which represents the decimal 0 to 9? Oh, okay. Okay, well, 1 sec. Yeah, so this digit is the ones place. That's 2, that's 4, that's 8.
That's 9.
You're right. That is 0 to 9. Okay. And then it would be 10. But BCD is only allowed to go from 0 to 9. So when the counter reaches 1010, we reset it back to 0. Okay. And design a 1-decade flip-flop counter. Flip-flops, okay. Okay, cool. This means Q3 equals 1, Q1 equals 1. And so the reset condition is Q3, Q1 is equal to 1. Use an AND gate connected to Q3 and Q1 and send the output to the clear reset inputs of all flip-flops. So the reset logic is reset Q3, Q1, and this makes the counter go from that. So 1, okay.
What's Q3, Q1?
So flip-flops are usually, these are things that hold either 1s and 0s. That's why it's called flip-flop.
Yeah.
And how a flip-flop works is if something is at 0 and you send a 1 to it, then it goes to sorry. This is, they represent them kind of like this. They're kind of like memory registers is what they are. The reason why they're called flip-flops is they alternate between states. So if you send in a 1 and then this is a 0, this ends up like pushing out a 0 and then this becomes 1. And then if you send, it just flips between 0 and 1, yeah. So if you send a 0 to it, I think if you send a 1 to it, it keeps staying as a 1. But then once you send a 0 to it,
yeah,
it outputs the 1 and then it stores the 0. I think that's what it means by like a flip flop. We could like look at this. What's that? Flip flop. Yeah, this is it. A little flip flop. Yeah, used to store multiple bits of digital data simultaneously. Each flip flop holds a single bit, a 0, 1. So an n-bit register requires n-bit flip flop sharing a common block to store an n-bit word. Yeah. What are we doing? What's up, Sticky? This is someone asked an electrical engineering question.
So a 0 just replaces a 1 and a 1 replaces a 0.
Yes. Yeah, here we go. What's the difference between registers, flip-flops? Yeah. Okay, 1 sec. Flip-flops are single-bit devices with 2 stable states, right? Either Q or Q bar. Oh, and then there's all these different types of flip-flops. SR flip-flops. Asserting either of these either sets or reset. After the input is deasserted, the flip-flop remains in the same state. Okay. JK. But they have a third property of both JK. It toggles.
I've worked with JK flip-flops.
Oh, really? Okay. Yeah, it says J is set and K being reset, but they have a third property, which is if both J and K are set, then it toggles. So that's what switches the sign of it. Okay, so if you send like a signal to the K, that forces it to be 0. If you send it to the J part of a JK, it makes it 1. And then if you send it to both, it just it flips it to the other state. That's what a JK flip-flop is.
Yeah, I slightly remember that. I don't remember it fully.
Yeah, then there's latches. This is all cool. It's all logic stuff. It's pretty fun. As to how that works with this, I think they're saying it. So if you had something that was counting to 999, was that the question? Oh, sorry. Okay, no. If you have it counting to 999, then that has to go from. Okay. Let me see. Wait, that's just for the. Okay, that's this one. Sorry. That the first question here was design a ripple counter for BCD to count in decimal. So a BCD ripple counter, 1 decimal digit using 4 flip-flops, but only uses the binary states there. Right. So that's what codes 0 to 9. But how does this go up to 999? Okay. And then to count to 999, now you need 3 of those 4 flip-flop groups. Okay. Every time the 1's counter goes from 9 back to 0, it sends a carry pulse to the 10's counter. And then when the 10's counter goes from 9 back to 0, it sends a carry pulse to the 100's counter. Okay. Carry is a cool thing we do for like, and these are how calculators work, by the way. It's really fun to see how you can do mathematical operations like addition and like multiplication just using 1s and 0s and using these logic functions. I did this. I taught someone in undergrad last year, this class. But the carry is similar to like when you're just doing basic math and you're adding the numbers, kind of like whatever. If you're doing like 10 plus, I don't know, or 12 plus 19, you'd be like, oh look, 2 plus 9, that's equal to 11, but then you got to carry the 1, and then the 1 tells the things in the 10's place that you have to add an additional 1. And so that's why that becomes 31. Yeah, okay. This is cool. I don't know if I can really like explain it or teach it so much, but the first one we got. This is if you ever take like any sort of like computer logic class, there's some really cool stuff here that explains how like calculators and things work. It's like the underlying structure of math. It's cool. All right. Who was this? This was Yoda. Ask E&M you shall. Or double E, sorry, not E&M. It was double E. Okay, Yoda's question. Took me 16 minutes. It said it was going to take me 20, so. We only did part of it, though. All right, let's go see who else is back in the queue. Let's go roll. See what we got. What? Choose winner, come on. There you go.
Let's go gambling!
Equity's got a pretty high chance. But nothing is ever for certain. But it is equity this time. There we go. Yeah, okay, I'll let you know. Too. Okay, here we go. Let's see what we got. Okay, so for the function, f of x is equal to x minus a times x minus b, where a and b are integer constants. F of 34 is greater than 0, f of 37 is less than 0, and f of 40 is greater than 0. What is one possible value of a plus b? Oh, wow. Okay. So greater than 0 means that something's positive. which means that like x minus a and x minus b. Right, let me not use this notation. Sorry.
Can I put in a preemptive guess on the answer to this?
Yeah, for sure.
6, 7.
Oh no.
34 and 37 are pretty random values.
Let's see if
guess that
you
it's
think
6,
it's.
7.
I don't. We'll see
Or
if it
it's
is. Yeah.
6'9" or 6'9", 420 or 6'7",
Oh
420 or
man,
something of the
that would be
sort.
funny if it is. Oh my god, Equity, did you get us here? All right. Okay, so if these two things multiplied by each other have to end up being positive, then x minus a, so this first part and this second part, they either both have to be positive or they both have to be negative. Must be both positive or both negative. Okay. Less than 0 means negative. So x minus a and x minus b have to be different, right? So x in terms of like positive, negative. So you could have x minus a is positive and x minus b is negative, or you could have x minus a is negative and x minus b is positive. Fascinating. Okay. And I needed to switch at a couple places. They did. Have all the kids stopped saying 6, 7? I'm glad it finally burned out.
Oh no.
Let's see. Okay. So 34 minus a, 34 minus b, it has to be greater than 0. Let me see if I can just like kind of see it. 37 minus a, 37 minus b, it has to be less than 0. And then 40 has to be greater than 0. I'm starting to think that I want a and b to be both less than 40. So that this is positive, this is positive. But then I want some switching to happen here. And then I think a and b must be less than 40. Such that this is going to be positive and positive. And then I think I want a and b to also be less than 34. Or, sorry, greater than 34. Because in that case, this ends up being negative, this ends up being negative, the two things are positive. And then there's going to be some sort of like switching case here at 37. Sorry, not a plus b, sorry. I'm saying the numbers individually. Yeah, say. Yeah, not a plus b, sorry, Jeff.
My name is Jeff.
Yeah, so I'm just saying the values of the numbers. Yeah. Maybe I should say this, a comma b. Is that better? Yeah. And then at 37, I need something weird to happen. So I need a to be like less than 37, but b to be greater than 37. Yeah, there we go. Right? Because then in that case, one of these would end up being positive and one of these would end up being negative. And then that's how you get less than 0. Okay, so what's the combination that makes this all correct? Well, b has to be greater than 37, greater than 34, but less than 40. So I think b is equal to 38. And then a needs to be less than 37, but greater than 34. So a could be equal to 35. Right? I feel like that would work, right? Let's make sure. Yeah, so 34 minus 35 would be negative 1. 34 minus 38 would be negative 4. Negative is positive. 37 minus 35 would be positive. 37 minus 38 would be negative, so that works as well. And then 40 minus 38, 40 minus 35. Okay, cool. So what's one possible value? There's actually a couple possible values for this, right? So this would go together and be 73. Right? Yeah. So not quite 60, not quite 6, 7. What are some other ones that would work? And I think they all had to be integers, right? So I would say like 38, 35. And then you could have had b is equal to 39. Or a is equal to 35. And then I guess you could have done b equals 38. A equals 36. Or b equals 39. A equals 36. I think that's it. I think there's 4. And then what do these all combine to? This combines to 75. This combines to 74. And then this also... Oh, sorry, I wrote 44. And then this also combines to 74. I think it's all of them. Let's see what chat would say. If there are any other combinations. Oh, and I see they talk about roots actually. Oh, that's actually pretty cool. They talk about more of a root sense. Okay, cool. So 74. Let me say, what are all the what are all? Yeah, this is also pretty good. Yep. There you go. So there are the possibilities, which I think is what we had. Yeah, cool. Good question. Oh, that made sense, Equity.
Well done! Well done!
Equity. Dun, dun. The bot said I should have been able to figure that out in 3 minutes. I don't know if I could figure it out in 3 minutes, but I had to write some stuff down. Okay. Yeah, you're welcome, Equity. All right, let's see what we got next. Spin the wheel.
Let's go gambling!
Discrete mathematics from Hello. Let's see, what is this question?
Aw, dang it!
Let's see if I know. I might have to just chat GPT this one. I don't know much discrete. Okay, S is a set of integers from 1 to 10. X is R to R. I've heard of this before. Equivalence relationships on the set S such that R has exactly 42 elements. The number of elements in X is... I think equivalence relationship is that you get the same thing back. Let's see. Here, explain this to me as someone who doesn't know discrete. It's a partition of the set. So it's like a subset? Is that what a subset's called? I'll try brute forcing. Okay. Breaking. Okay, here we go. So here we go. An equivalence relationship is a way of sorting the numbers into groups where everything in the group is equivalent. So if we had a set from 1 to 10, right, we could group it this way into subsets, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then everything inside each group is related to everything else in the same group. The key idea is that if a group has a size k, then it contributes k squared ordered pairs to the relation. Okay, whoa. Where's the ordered pairs coming from? Sorry. I think that's the first part I'm getting confused with. XRR. Okay, so I guess it's called an ordered pair because you have an input and an output. And then why is it n squared? Oh, I see. Because... Okay, let's think about this. So if, for instance, squares not triangles. Yeah, maybe. Okay. So let's say, for instance, it was 1, 2, 3. Yes, thanks, Jeff.
My name is Jeff.
Right. So this key part here means that I think you have this, right? You have like an input output type thing. So you could have 1, 1, 1, 2, 1, 3, or you could have 2, 1, 2, 2, 2, 3, and then you could have 3, 1, 3, 2, 3, 3. Right. So and that's why you get 9. So n squared elements, right? Is that what we say? N squared elements? Dun, 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 dun. 36, 4, 1, 1. Okay. 10 choose 6, 4 choose 2 was your guess. And then wait, when they're saying, so this is counting. So, all right, this would have, I see, this would have 9 elements. And then what else could I have then, right? So 1, 2, 3. And then if I wanted to then just do individual sets like 4, 5, 6, and so forth, right? Then each one of these would contribute just 1 element. I'm trying to like think of it as like a puzzle, right? So this would be 9, and then like 4, 5, 6, 7, 8, 9, 10 would contribute another 7. And that would be 16, which isn't enough. But okay. So you could do it as a set of 6, is that what we're saying? So if I have 1, 2, 3, 4, 5, 6, this contributes 36 elements. And then, so if I did 7, 8, 9, 10 as single elements, that would get me up to 40, which isn't enough. So, what if we did 7, 8? That would get me 4 elements. Oh, okay, cool. And then 9 as its own thing, and then 10 as its own thing. Right, good. And then this is 1. This is 1 element. And so that gets you 42. Femvox says 36 plus 4 plus 1 plus 1 because the square roots of those add to 10. Why did you end up picking that, Femvox? That they square up? Yeah, if you had 2 sets of 5, that would be 50, right? Oh, apparently 5, 4, 1 works as well. Right? 25 plus 16 plus 1. Oh, and then you have to do what all the equivalence relationships are. Oh, which is how many ways? Oh, how many ways? Oh, I see. Because in picking this group of 6, for instance, I could have done like 1, 2, 3, 4, 5, 7, and then this one could have been 6, 8. But you don't have a choice with the last 2. Oh, very cool. Right. Okay. I see. So yeah. So this ends up being 10 choose 6. And then once you've chosen 6, you have 4 choose 2? And then you have, well, you don't get any more choices for these, right? Because choosing this one and choosing this one doesn't do anything. Yeah. And then the last 2 are singles, right? So, yeah, that's 2 10 times 6. But then these are forced. Yeah, cool question, hello. I see. Discrete math is kind of like puzzle math. It's like fun puzzle math to me. Yeah, and the other way would have been to do 5 elements. So 1, 2, 3, 4, 5. And then plus 6, 7, 8, 9. That would have been 4. And then plus the single. So this would get you 25 plus 16 plus 1, which is then 42. Oh, yeah. Okay, so then it would be 10 choose 5 plus 5 choose 4. Or, sorry, times 5 choose 4. And then just times 1. Yeah, okay. Okay, cool. And then you just add up the total ones. Right, and so this is equal to 1260. Right, okay, very cool. Okay, so 2520 total. And so when they say equivalence relationship, we're saying that all the numbers here are the same. So, right, okay, I see. 1 is equivalent to 1, 1 is equivalent to 2, 1 is equivalent to 3, 2 is equivalent to 3. I see how, like, the pairs work now with the squares. Man, very cool. Oh, you're very welcome, TMK. Yeah, I'm glad I helped you out. This was a fun question. I like this discrete question. This was cool. Kind of makes sense to me now. You're very welcome, TMK, though. But that was helpful. Femvox says, if you have the set A, B as an equivalence class, the relation has elements ARA, ARB, BRA, and BRB. BRB. Okay, I see. Yeah, it's cool to think about. Okay, let's see what else we got. I still got a little bit of time. Let's see what other questions we can do.
Let's go gambling!
Ken just submitted one. What's up, Ken? Nitro. What is Nitro? I might not be able to do this one. I might have to instant pass on this. Yeah, I don't know what a linear time invariant digital digital type 2 R filter by a transfer function. I don't know. Breskles, is your mic trying to work or something?
I was gonna say something and then I read the rest of the question and thought, no.
It's okay.
I saw linear time invariant and I was like, I know that. And then the rest.
I can check.
I could see.
Yeah, I don't know what direct form direct 2 is. So yeah, I'm going to punt on this one. It's okay. It happens. That gives us an opportunity to spin the wheel again, though.
Let's go gambling!
Yo,
What's up,
take
Jack?
off the water time limit, please, for like
No,
one
'cause-
stream, bro. For
No,
one stream.
people try to drown me, dude.
Exactly, for one stream.
I don't want to get drowned.
Just
I
take
don't
it off. Just take it off.
take it off, dude. I would drown, dude. I do need more water.
Take
I
it-
need to refill this.
Take it off and set the limit to 1 coin for one stream.
People would just be
How
like
many,
spamming the water sound all day, dude. It would be really,
How
it'd be
many
hella annoying.
questions have you done?
Today? I can check. One sec.
Yeah.
Mm-hmm. 1, 2, 3, 4, 5, 6, 7. We've done 7. 7. Not 6, 7. We've been told that
So now,
we've been told that the 6,
Uh-huh.
7 doesn't happen anymore. You guys don't say 6, 7 anymore.
nah, I still say it.
It says real. Oxidation of an alkene gives a diol. Further oxidation gives a diketone. What could be why? Oh man. Okay. I know oxidation.
Everyone, start the prediction. Whoever gets the highest prediction and has a question answered, I will gift you my $10 gift card reward. Yep.
What's the
Answer your
prediction?
questions now. It's on Twitch. Will Gold get 10 questions by the end of his streaming session?
Well, but my stream just ended right now, though, dude. What?
I'm thinking my answer no right now.
Oh no, I'm canceling this. I'm alting this. Alt cancel. Yep. Alt cancel this and delete this. Yep. Take this out.
There
Yep.
you go. There you go, Shaq. Okay.
Yeah.
Oxidation
Whoops.
is loss of electrons.
Oops. This lost hella aura. Matter of
okay.
fact, you know what? No, I didn't. Go drink some water. Go drink water. And go
Wow,
sleep
see, the
like a
timer's
baby.
back.
Yep. Yo, have a good day, guys. I'll catch y'all next week.
Thank you,
bro.
Shaq. Okay. Oxidation is loss of electrons. What could be the dude? Ugh. This is organic chemistry. This isn't standard chemistry. What did the thing say? Standard AP organic chemistry. Is there even an AP organic chemistry like class? What?
I don't know.
I don't know about that.
I've heard it.
This says, yeah, I don't know too much OChem, unfortunately. I know what these words are. I know what like a diol and a ketone is. AP Chem might have OChem in it. It might now. I don't remember having AP Chem having OChem in it when I was in it. Let me give you a shout out, Zach. Sorry, I probably forgot to shout you out today. My bad. There you go. When an alkene is oxidized to a diol, the double bond becomes this. Yeah, it didn't for me either. When you got the 2. If I recall, yeah. A secondary alcohol can oxidize to a ketone. A primary alcohol oxidizes to an aldehyde. A tertiary alcohol does not to get a diketone. Both alcohols in the diol must be secondary alcohols. Okay. I think I see what's happening. The double bond in the C becomes COH. Yeah. And then each carbon with an OH bonded to it. Okay, each carbon with an OH bonded to an H, a phenyl group, and another carbon. Each carbon with an OH is bonded to an H, a phenyl group, and another carbon, which makes it they're both secondary alcohols. So further oxidation gets you this, which is a diketone. Okay. Man, dude, this is a lot of memorizing. Like, I wouldn't remember like which types of alcohols can oxidize to what other type of organic functional groups, and then also having to remember like what's the definition of a secondary alcohol versus a tertiary one. Yeah, this is why OChem's tricky, but it is necessary if you're trying to become doctor. So, okay, here I'll share the solution to this one, but I know what the words are. Like, I know what a ketol is. I know what an aldehyde is. But I didn't know these definitions of what makes it a secondary, a primary, or a tertiary, and then like which ones can oxidize to other ones. You got to kind of just like memorize that stuff at that point. What's up, Couch? Yes, Couchy Techno. So we posted the answer to that one. So if you want, there's a link there for the ChatGPT article about it. But yeah, okay. Let's see. I'm feeling generous. Let me keep running. I'll keep running a couple questions. Let's go choose a winner.
Let's go gambling!
Oh, there we go. It's breasticles for the Calc 3. So here, let's go at Tuma. Ooh, okay. Wait,
yeah,
Koshi
ignore
Riemann.
ignore the analytic part. Just hit partial derivatives. The partial derivatives are the only are the calc 3 part.
All right.
There we go. Okay, cool. So this is what part am I ignoring, Breasticles?
The bottom part that's like determine where it's analytic and express FMV.
Oh, okay. Okay, cool.
Because that's just complex analysis part. But the
Okay.
Cauchy-Riemann conditions, you just need partial derivatives. That's all.
Okay. Tuma, do you understand like what UX and UI and like VY mean? Have you seen that before?
UX, is that a point?
So UX means it's the partial derivative of U with respect to X. And then VY means it's the partial derivative of V with respect to Y.
What does that mean, partial? Like how can it be partial?
Partial means that when you're taking the derivative, you only consider this variable as something that you take the derivative of things of. So, for instance, let's look here, right? So, like everything else is treated as a constant. So, let's look at this one, for instance. V x comma y is equal to 2xy plus 3y. Do you see how there's like x's and y's in this? So
yeah.
Partial v, partial x means I only consider x as something that is varying. And so that's the only thing that I need to do derivative rules on. So
it's asking you to focus on that only.
Yes, and you treat everything else as a constant. So y is basically like another number, okay? But not something you need to take the derivative of. So otherwise you'd have to do this as like a chain rule or like a product rule, really. So in this case, yeah, go on, Breasticles. You probably explain it a little bit better than I can.
Yeah, so for a partial derivative, right, if you imagine the limit definition, it would be of two variables rather than just one. And so when we're doing that limit, we can just basically ignore the other variable. And so in the case of a partial derivative, we would just take the derivative normally, treating it as a constant, if it's not x. So say for example, no, so you wouldn't have you wouldn't have a plus h on the y.
Oh.
In this case.
Oh, I see.
Right. So if it was respect to x, it would just be x plus h. If it was respect to y.
Okay.
X
So you're saying,
correct.
so partial f partial x would be like doing the limit definition of a derivative, which is just basically the slope of two things.
And you can only do this for derivatives?
Mm-hmm. The partial stuff, yeah. Although Breasticles was doing quote unquote like partial integrals earlier, which don't worry, you don't really deal with those.
Like an antiderivative, right? The integral being an antiderivative, you just say, oh, we're partially integrating. It's the same idea when you do a double integral and you treat something as a constant or treat a variable as a constant.
Yeah.
But we don't do that.
No, not
You'll
yet.
get there eventually on double.
I don't think you'll
integrals.
get there in Calc 3.
It's not as bad as it seems.
So, yeah, in this one, the y is considered like just another number. So what's the derivative of a number times x, right? If I wanted to do ddx of like a number times x, what would that derivative be equal to?
Just the number.
It would just be equal to the number, right? Yeah. Right, because this would just come down. Yeah. So it's kind of the same thing here. You're saying like, oh, this 2 and this y are just numbers. And so the derivative of x is just 1. So this ends up becoming 2y. And then again, if this is just a number that doesn't depend on x, what's the derivative of a constant or of a number?
0.
0. Good. Yeah. So this would be 0, right? Okay. What would dv dy be then? Or partial v partial y, sorry.
dv dy.
Mm-hmm.
That would be just 1.
So you're gonna. This is v. This whole thing. So you're gonna look at the derivative of this. It would be 2x. Right? Because the x is considered just like another number.
Oh, right.
Okay. Then, but what about this part?
3.
Good. Yeah. So you see how this is partial v partial x, this is partial v partial y, and the other way we write this for as a shorthand notation is we say this is like v with a subscript x, and then this is v with a subscript of y. Okay.
Oh.
So then let's look at what u is. U was equal to, let's see, they had it was like x squared minus y squared plus 3x. Okay, so let's try to figure out what partial u partial x would be equal to.
Wait, how did you get u?
U is given to us. They just gave it to us. They gave us a function u. They gave us a function v, and then the Cauchy-Riemann equations. These are special things. You don't have to know this particularly, but is ux equals vy, and then uy is equal to negative vx. These are like special properties. Just for this question, and what we want to do is we want to verify that this is correct for this this thing, I think.
And so you have to take the derivative of that too.
Yeah, right. So what's partial u partial x? What's up, AFG? There's a wildfire. Oh, I don't know. LA burning again. There's a big ass wildfire. Is there? Wait 1 second. Let me make sure I'm not burning down. Active shooter in San Diego. Oh dear. Fast moving wildfire, but where is it? Oh, it's burning. I think it's away from me. I think it's like, oh, Simi Valley. Oh, Simi Valley's far from here. We're okay. I mean, not good for Simi Valley, but Simi's like an hour and a half. Simi's like an hour and a half, like 2 hours from here. Although I guess maybe wildfire doesn't care about traffic.
Emotional, damn it!
Is it close to you, AFG? Oh my god!
No, AFG, don't say that, dude.
Oh no.
Don't wish bad things on him.
No, I mean nothing happens to him, bro. But like,
But what, you hope his house fires this burn? I don't want anything bad to happen to him other than losing his shelter.
No, you don't know. He's a very bad person. It's just
he's a very bad person.
I hate him. You know what happened one time? There was this girl in my class, and during the test, she broke her like right arm or something.
She broke her arm? How did she break her arm during a test?
No, like before taking the test. Like something happened and she broke her arm.
Yeah.
And she's right-handed, so she couldn't write. And bro, this dude made her write the test with her left hand.
Wow.
Damn.
That's
Builds
so
character.
It builds character.
Oh no.
That's crazy. Bill's character is crazy, dude. Like,
Crazy.
Yeah,
I mean,
someone
all
did
I'm saying, her handwriting may have been terrible, but like, because it was
Yeah, well, I mean,
left
then you
hand,
put
but at
up
least
holes
the
for not
answers
having
would still be consistent
What-
with her mind. Her mind.
That's
didn't
true.
break, just her hand.
What's the alternative though? I'm curious. What would the alternative be if would we let her take the test later or what?
Yeah, just let her take it later or something. I mean, I don't know.
Or have somebody write for her.
Yeah, or that. But like, I mean, just ask her to take it later or something. Like, that's so like.
Wait, broken hands are like
inhumane.
a couple weeks though, no?
Make it right with her recessive hand. Like, what the
Yeah.
hell? Bro?
Or maybe like type things up. Maybe she could probably still type, right? Sounds like something
I don't know,
Sensation would say.
Imagine typing with your broken hand like that. That would suck.
I don't know. I had what was it? I had to get pec surgery like the day after I defended my thesis, which was like brutal. So like my whole like right side was like fucked up. But like luckily I could still like do this with my fingers. So as I was like typing up my PhD corrections, I was doing it on probably like 2 Percocets and like barely like
damn
like move my, yeah it was
Yeah,
brutal.
I mean, I think if Stephen Hawking could do everything he did without any arms,
Damn.
then
Where is
You
this fire? Oh, I see. Yeah. Oh, it's right by Thousand Oaks. Oh, dang. Okay. Yeah, this is still decently far from me. So I appreciate the concern at least. But you guys don't need to worry. This would take a while for it to like to get to me.
I need to worry.
Do you live in Simi Valley? I didn't even know you lived in Los Angeles, dude. What?
No, I do.
Okay.
It's not LA. This is not LA. It's like this is
It's
still
close.
Southern California.
This is technically LA County. Do you see how this says LAC?
Yeah, I
This
know
is
it is LA County, but
this
I
is
live
technically LA
like,
County.
Down, there's a city called Oak Park.
Oh, okay. Well, you're clear so far until this like gets this way.
I don't care. I can run away. Like I just hope my teacher.
Yeah, just hope my teacher's house burns down.
Oh
Yeah. Not even the house, the chemistry final that he has. All of the finals burned down, and that he has to like round everyone's grade up and be like,
Y'all are
no
cute.
final.
Y'all are cute. Well, it looks like the fire's really only here so far. Well,
That's where it originated
Danny
from.
keeps
Like
fire.
they haven't contained it.
Okay. Well,
Damn.
I appreciate you guys looking out for me. I'll be okay. All right. Let's
You like
finish up the
animals?
rest of this question because I do want to like go eat dinner and stuff. Partial U, partial X. Tuma, how would I do this?
So that would be 2x minus y squared.
No, not minus y squared. Remember, if we're doing partial x, y is a constant. It's just a regular number. What's the derivative of just a regular number?
Oh, just like 1.
No, 0.
Oh
Derivative of
wait,
number
but
is
in the
0.
last problem, you kept y.
Okay, so in this one, right, the y was being multiplied by something that we were taking the derivative of. So that's why it stays, right? So for instance, if I have like y is equal to like 5x, then dy dx is equal to 5, right?
Yeah.
But if y is just equal to 5, well, dy dx is equal to 0. Because this is the same thing as like 5 times 1. And then another way to write 1 is like x to the 0. You see if you did the power rule, right? Bring the power down.
Yeah.
You get 0 times something, so this just goes away. It's another way to
So then
think.
anything in terms of y would just be considered a constant?
Correct. Anything that's not x is considered a constant. And so the reason why, in this case, when we were taking the derivative with respect to x, the reason why the y survived is it was still being multiplied by x. So this derivative happens, but then this still multiplies by what the result of that derivative is. And the derivative of x is just 1. So that's why it survived.
Right. So then it'd be 2x plus 3.
Good. Zeusy says, uncle. Oh, wow. I got called full uncle. Not just unk. I got called full uncle. Uncle, I have my aptitude test in 2 days. I'm nervous. You got any tips? It's timed 35 questions algebra. It's natural to be kind of nervous and afraid of like exams. The best way to get over that like anxiety is to practice taking exams in the same conditions that you are going to take the actual exam. So if you know it's 35 questions and it's timed, try doing your own little, I don't know, even you could do like a 10 question practice thing and have it be timed and just see how much time it takes you to do it. So put yourself in those conditions. That way when it happens for real, it's not super strange to you and it feels chill. You're just like, oh, I've been here before. Okay, what about this one? How to do partial U, partial Y though? What's that?
So the x's are just constants, so they're all
Good.
0, and then it'd be negative 2y.
Good. Exactly. And yes, all the x's are constants, so derivatives of just them, yes, are 0. If there was a y attached to this though, this would end up being, the derivative would be x squared.
X squared.
Because, yeah. Right?
Mhm.
Okay, so there you go. So there you go. So there you go. We figured out, and this, right? This would be u subscript y, and then this would be u
Wait,
subscript
what if you had
x.
like a quotient?
Yeah. Okay, so what if you had this? What if you, let's say, for instance, u was equal to x squared over y, and you wanted to figure out, is that what you're saying, like ux? What would that be equal to?
Yeah.
Well, okay. Remember that division is kind of the same thing as like multiplying by the reciprocal. So this is the same thing as 1 over
just x
y
squared, so it'd
times
be
x squared.
2x over y.
Good, exactly. You're right. Yeah. So ux would just be equal to 2x over y. Very good. Yeah.
But if it was on the bottom,
Okay, sure. You want to do?
you'd
Let's
have
do
to-
y over x squared. Or actually, let's leave it how it was.
I get it.
Do you get it? Yeah.
Yeah, you'd make it negative.
Right. So ux in this case would be equal to 2x over y. What would uy be equal to?
Uy, like with respect to y?
Yeah. So now you're taking the partial list with respect to y.
Oh, dang. That would be like, I know x would be like 0 because it's a constant.
But again, let's think about this, right? The other way to write this is you could say this is the same thing as x squared times 1 over y. Or you could think about it as x squared times y to the negative 1, right?
Right.
Okay. So now this doesn't become 0. It's a constant. So when I take the derivative of this with respect to y, what am I going to get?
It stays with it. It's 2x times y to the negative 1.
It's not 2x. This is the derivative with respect to y.
Oh, no, that
Partial.
one, yeah, that one. Which one are you asking me to
Well,
differentiate?
these are all the same thing. They're all the same.
Yeah.
It's just 3 different ways of
So-
writing it.
I mean, are you asking me to differentiate the ux or u?
Differentiate the u. U is equal to the same thing here.
With respect to y, right?
Yes.
So then it would be it'd be 1 I know x squared. Oh my god. X squared comes along, right?
X squared comes along, right? It's just like a number.
And then it would be negative 1 y to the negative 2.
Good. There you go. Right. So this would end up looking like x squared over y squared, and then with the negative out in front.
Yeah.
Yeah.
I get it now.
Cool. Right. So that's how that one would work. Okay.
I understand it now.
He's getting there. He's getting there. All right. So you figured all these out, and so the Cauchy-Riemann, they wanted to verify, does ux equal vy? Well, let's see. What did we get for ux? Ux, we got this. And then vy,
Yeah.
we got this. So do you see how ux does equal vy?
Oh, wow.
And then does uy equal negative vx? Well, uy was negative 2y, and then negative vx would be negative times 2y. So yeah, they work as well.
Huh. Oh, wow.
Yeah, very cool.
That's
so
it.
That's it. That's it. Yeah, that's how you do it. Yeah, nice.
Oh, wait. What does u stand for again?
U is just a function. So here we're saying that like u is this function, v is this function, and then so u sub x means taking the partial of that u thing with respect to x, and then
Oh.
right.
What's that thing on top of it?
Oh, don't worry about this. This thing here. Yeah, you don't need to worry about this. I don't think you need to worry about this. This is like a super function, which is equal to whatever this is, right? Plus I times whatever this is.
Yeah.
Oh.
But, yeah, z would be x plus iy, and then your f of z would be, that's basically saying u is your real part of the like a complex valued function. Use your real part, and then you're multiplying by I, and V is whatever function is represented your imaginary part.
Femvox went ahead and did the part we scribbled out, because this is the part that we weren't going to have you solve because it's a little bit more advanced than what we're trying to teach, which is just intro partial derivatives. But Femvox did get it correct and said that f of z is equal to z times z plus 3.
Yeah.
That'd be cool to see how you got that, Femvox, but nice.
It's just factoring. You would just want to, because each z is x plus iy, so you would factor it in terms of your z. Generally, in complex, you can kind of hop to it's probably going to be a quadratic of some form if you have like a cross term, like an xy, like a 2xy. So
cool. That was fun. Nice. Thanks, Bresico, for finding that one, and good job, Mathan Tuno, for getting an intro into partial derivatives. That is definitely a Calc 3 topic. That's fun. Yeah, isn't it fun to like learn math when you don't have to do it for a grade?
On God.
On God. Okay, cool. Well, yeah, keep take those textbooks we sent to you, and I know it's hard to want to like self-study and do stuff, but maybe just try to teach yourself and like look at the questions in the back, and if they don't make sense, like you can bring them here on the stream, and like I'm happy to like teach them.
Hell yeah. I've learned to suffer, so I think I'm gonna start enjoying it more.
Good. Yeah. We'll get to it eventually. Okay, cool. All right, I'm pretty much over time, so let's close the stream. All right, thank you everyone for coming to Actual Education Office Hours today. Appreciate all your guys' feedback. Hopefully this Simi Valley fire does not spread down to where I am. That would really suck if it did, because also we just dealt with a fire like last year. It was really bad. I had to evacuate and everything. You guys were here on stream, I think, when I said like, oh yeah, I gotta close the stream down. The fire's getting a little bit too close to home. So I appreciate AFG you like warning me for that. I didn't even know there was a fire in LA. But anyways, I'm leaving on Wednesday for Europe, so even if there is a fire, I guess I won't be here. But all my stuff would burn down. That would be unfortunate.
Yeah, for everyone else.
Yeah, I'd be like, peace. It's like that one meme. The guy who's like, he's like, peace. But so our last stream of the month will be tomorrow. So come on by. We'll help you guys out with whatever math, science, homework you have, and then I will be out in Europe for a wedding and family stuff. So I do not foresee myself coming back to streaming until probably early, like the first week of June. But as always,
that's not bad.
Yeah, it's not too bad. Yeah, I'm gone for just like the rest of this week and all of next week. But then I'll be back.
Tomorrow's the last stream?
Tomorrow's the last stream for at least a week and a half, yeah. Because I gotta go. But if you ever want to figure out when we're streaming, we always have the calendar. So go check out the calendar. Has all the times that we're on. So while I'm gone, Zach will have, look at it, Zach's gonna be doing category theory. Oh, that sounds cool. And then Zach also has his math Q&A sessions. So tomorrow's I have to move up a little bit early. We usually stream at 6 o'clock on Tuesdays, but I got to move it up a little early because I got to pack and stuff. So
dude,
Zach and I are gonna have. Card looks sick. You like the gold one? Yeah. I found out a way to do it. Anybody else on our calendar, if you want like fun little design things, I can figure out how to do it. For now, I just had everyone pick a color at least. But attempts, yes. Thank you, Femvox. Appreciate it. But yeah, oh yeah, it looks, yeah, Justin's gonna have streams on Thursday. So yeah, we have a whole community of awesome people that are still gonna be streaming. We have no streams that following week, but I think I do have it scheduled. Yeah, we'll see how jet lagged I am. So I will update this whether it's Sunday or maybe it'll be Monday, June 1st. So yeah, thank you guys.
Oh yeah.
Yeah. Okay, cool. Let's go. Say hi to somebody else on Twitch. We're gonna go raid. Who are we gonna go raid? Who are we gonna say hi? Oh, of course. Yeah, no, Coach Tech, yeah, you can keep sending those questions all day. We appreciate, even if there are things that like we don't normally do, it's fun to learn new math. And I really appreciated learning today about equivalence relations and a little bit of discrete math, even though I've never taken the class before, but that's very, very cool. let's see. Who's on? What is Nerduino? There's a launch happening? What's there happening? Or Nerduino's live launch ESA Smile mission. Let me see. We probably say hi to Nerduino. Let me see. Is there anyone else I haven't rated in a while? Draw Curiosity is doing a 2-year streamiversary. Oh, that's pretty cool too. Yeah, I haven't said hi to Ines in a bit, and I think she moved. Yeah, she's I forget. She's a biologist streamer. She's cool. All right, go say hi to Ines. She's fun. All right. Enjoy the rest of your Monday. We will see you on Tuesday. Peace.
See you.
Peace, guys.
Peace. I have an infinite integration by parts question for you, by the way.
I love it. Do it.
But I have noticed
Infinite.
that the older I get, the less. Oh my god, Actual Education, thank you so much for the raid.
Actual Education raided my stream with 10 views.
Thank you so much for the raid. How is your stream? For anyone who enjoys science content, you should go drop Actual Education a follow. For anyone who's new, hi, my name is Dr. Nace, rhymes with face. I have a PhD in insect flight biomechanics. I am drawing a bug right now. I'm best known for my science videos on YouTube and Nebula, and I stream variety. My voice is a little fucked right now, so that's why I'm speaking like this right now. But welcome in. How was your stream? What were you up to? Thank you so much for the raid and the kind words. I have added 2 daily bugs to the decks today. Well, they will hopefully. I think I've got enough that I'll add them